Vue is a JavaScript front-end framework that's lightweight, flexible, progressive, and very easy to get started with, allowing you as a developer to start creating apps in no time. It's flexible in that you can use Vue to control only a portion of a larger pre-existing web page or site. Say for instance you only want to augment a portion of an existing web page with some extra functionality, or you can drive your entire interface as a Vue app just as easily. Because Vue is lightweight and modular, it doesn't require you to install anything but its core files to get up and running. But that said, if your front-end app does require more advanced features like client-side routing or state management, for example, it's very easy to add these into a project at any time. When working with Vue, we build up our apps as a series of independent components where each component controls its own template, its own JavaScript that drives that template, and its own styling information, completely separate and apart from the rest of the app and other components. Once we have a series of components that provide some functionality, they can then communicate with each other easily to pass data and emit events, and they can also communicate with remote servers to pull data into the app on an as-need-be basis. Lastly, Vue also has an excellent CLI command line interface that makes developing, maintaining, testing, and deploying Vue apps trivial. In fact, using the CLI as a starting point is a highly recommended approach if your entire interface is going to be driven by Vue. The tooling, scripts, and support that the CLI provide really facilitates rapid development. In this video, we want to look at how we can install Vue for use in our web apps. Now, the installation guides are going to be available on the Vue website, which is VueJS.org, and basically there are going to be a few options we can pick from. The gist of this installation page is letting us know that our options are to either install Vue in our app directly using a script tag, or we can install it via npm, that's the Node Package Manager, or we can create a new app using the Vue CLI or command line interface. Which option you choose is going to depend on where you are in your development lifecycle and maybe other specifics about your business environment. In case 1, where we choose to install Vue into our app directly using a script tag, we basically have a few different ways we can access Vue. From the Vue website, we can actually download the VueJS library, either a development version or a production version, depending on where you are again in your development lifecycle. And then you would pull this in or locate this in your web app and link to it, typically from an index.html page. As an alternative to that, you can also just use the script tags provided on the installation page on the Vue website to grab Vue directly from a CDN, or content delivery network, whenever you need it. Again, in this case, you can get different versions of Vue depending on your purposes. You're going to be able to get a learning version by using a particular script tag, or you're going to be able to get a production version by simply hitting a different URL. Moving on now, if you had a project that was already created and managed via npm, then you're going to be able to simply add Vue to that project by using npm install Vue. Typically, you'd also add a --save to make sure the Vue library is listed in your package.json file as a project dependency. And when you go this npm approach, Vue is going to be in your node modules folder, and you're going to be able to link to it from there. Finally, the last approach we talked about was using the Vue CLI, the Vue command line interface. This is the approach you're going to take if you're looking to create a project that's entirely based on a Vue front end. You would install the Vue CLI globally on your machine, also using npm, and once the CLI is installed, it's going to expose to you a whole ton of commands that you can use to get up and running with Vue. In our demo here, we're going to be using approach number 1, so we're basically going to use a CDN link and add a script tag into our app. On screen now, we're looking at our app's index.html page, and you can see it's pretty basic. Not a whole lot to talk about in here at the moment, other than to say our app basically at the very end here is linking to another script tag, main.js. You can see it in our project structure over here to the left of the screen. And if I were to click on it, you can see that right now main.js is pretty bare. Going back to my index.html page now, to install Vue for use, I'm going to just get some space here on line 13 and paste in another script tag, and as we mentioned, this script tag is going to have its source attribute set to the location of the CDN that can deliver us the Vue JavaScript library. Basically, that's all there is to it. other than to point out that we want to make sure we include the script tag ahead of our main.js file, since we want Vue to be available for use in main.js, assuming that's going to be our main application JavaScript file. So now at this point, Vue is installed for our particular project here, and the next thing we would think about is installing the Vue development tools. In this video, we want to look at installing the Vue dev tools and also setting up our environment for Vue development. In the demo app we're working with, we've already installed Vue for use, and if you need to see the different ways that we can do that, it's covered in the topic Installing Vue. The dev tools themselves are not project specific, but rather they're a set of browser tools that are going to greatly aid us in Vue development. Depending on your browser of choice, you're going to be able to get the tools as either a Chrome or a Firefox extension from the respective browser stores. We're going to be using Chrome in this video, so we're going to be able to go to the Chrome Web Store and use the search bar to search for Vue. Typically, the first result that pops up is going to be the one you're looking for. As you can see, it's the official vue.js dev tools, and I'm going to be able to use the Add to Chrome button to install this extension for use in my browser. Now, normally the Add to Chrome button would show up just as it does in the second listing here, but since I've already added it, I just have the option to rate it instead, and there's also a little tag along the upper left of the listing telling me that it has been added. The definitive way to verify that the extension has been added is that it should show up in your extensions toolbar. You can see here I have a grayed out logo. If I hover over it, it says Vue Dev Tools, so I know it's installed in my browser, and even though it's grayed out now, this is because the current tab I'm on doesn't contain a Vue app, so the extension remains inactive. Once we go ahead and navigate to a tab that does have a Vue-based app going, then this is going to light up and the actual dev tools are going to be available to us down in the Developer Tools section. For now though, seeing it in the toolbar is good enough. So now with our dev tools installed in the browser, let's look at setting up our development environment to ease Vue app work. We're working in Visual Studio Code, so the approach we're going to take here is to install a few key extensions related to working with Vue. Many modern IDEs are going to have a similar extensible approach where you can add in support for Vue, or they may already have that support built in. Here in Visual Studio Code, I'm able to manage extensions by using the Extensions button, the square icon along the left side of my interface. Clicking on it is going to take me to the Extensions Marketplace where I can search for different extensions. So if I were to search for Vue, you can see I have a lot of different options. Usually some good clues as to which of these are considered very useful in the Vue community are going to be their ratings and their download counts. A few of these that I've already installed as part of working with Vue are Vtur, which as you can see provides Vue tooling for working in Visual Studio Code. It's also very popular with over 10 million downloads at this point in time. I've also previously installed ESLint, which enforces rules around code structure and essentially makes sure that we write clean code that conforms to industry patterns. As I said earlier, there's a lot of different great extensions here, so depending on your needs, you're going to be able to go through this list and see how to best set up your environment. Probably by the time you watch this video, the ones I've installed may or may not be available, may not be as popular, or maybe they'll be even better than they are now. Also, as I said earlier, you're going to be able to get an idea of what people are really using just by taking a look at the ratings and the download counts. At this point now, we've installed Vue for use in our application, we've set up the development tools in our browser, and we've added a few extensions here in VS Code to help us. So the next thing we would likely think about would be to probably get started with creating a Vue instance. In this video, we want to look at setting up a Vue instance. The Vue instance is really at the root of our Vue app, and you're going to see that how we configure it is really what drives our app. In the simple app on screen here, we've already set a few things up. Namely, as you can see on line 13, we're linking to our Vue framework via a CDN, and right below that on line 14, we're linking to a local script file here, main.js, which we're going to jump into in a second. It's going to be the root of our Vue app. Other than that, the only thing we're doing in our HTML here is setting up a div here on line 9, and you can see we're giving it a specific ID, the food app, which you'll see come into play later on. Within that div, we're using a h1 tag here to set up a title, the food app, and an h2 tag right below on line 11 to set up a subtitle, this is an app about food. So now, given this setup, let's jump into our file here, main.js, and as you can see, at the moment it's empty. To create our Vue instance, we're going to use the Vue constructor, which is exposed to us by the framework. We're going to here on line 1 create a variable app as new Vue. What we pass into this constructor is an options object, and exactly what we pass in here determines how the app runs. Right now it's empty, but let's expand out our options object a bit here, and the first property we want to pass in is L, short for element, which basically allows us to specify a string that can target some DOM. When we use L like this, the place that we target, the DOM that we target, is going to be where the Vue app is going to be placed at runtime. Now, quickly popping back to our index.html file, you'll remember we do have our div here with ID, the food app, so we're going to use that as our selector. Now that our instance has a place to live, the only other thing we're going to set up is the data property. The data property is going to allow us to pass in an object with many key value pairs, all of which then become available to us in the Vue instance. To test that out, I'm going to get some space here on line 2, drop down to line 3, and add in a key, data. And as we said, it's going to be an object. And now any custom keys I put here are going to be available to me in my Vue instance. For the sake of the demo, I'm going to set up two keys, title and subtitle. And once these are in place, as we said, when the app runs and attaches to our div, we can actually render this data into our div via interpolation. So I'll save my main.js file, and let's go back to our index.html. And now we know that this div here, the div with ID, the food app, is where our Vue instance is going to run. This means that we can jump into our h1 tag here, and instead of this static, the food app, I can use interpolation to access the data setup on my Vue instance. We're going to do the same thing for our h2, replace our static subtitle here with our data-driven version. Saving all of this, you can see now in just a few lines of code how easy it is to set up a Vue instance that's really able to target any discrete part of the DOM and then be off and running. Naturally, there's a lot more you can pass to your Vue instance's options, but for the time being, this is all we need to see. Since my app is being served up by a simple HTTP server, I'm now just going to jump over to the browser here, refresh the page, and as you can see, we're now getting our title and our subtitle, both of which we now know are coming from the data we set up as part of our Vue instance. We're set up here in our Vue app, and we want to look at attribute binding in Vue. Now, attribute binding is a one-way data bind where we can set an HTML attribute based on a value coming from our Vue instance. If at any point in the future the value then changes in our Vue app, then the appropriate attributes are going to be updated and the DOM is going to be re-rendered to reflect that. Before we jump in to see how all of this works now, I'll point out that in our very simple Vue app here, we have a folder images that if I expand it out, you can see contains some images of different foods, some of which we're going to be using later on. Pushing on now, our app is already set up with a Vue instance, and if you want to see exactly how that can be done, you can check out the video titled Setting Up a Vue Instance. Going over to our main.js file here, taking our current setup, what we want to do is add some more data that we can then render over in our HTML. In fact, I'm going to jump into my data object here and get some space on line 6 below my subtitle key and paste in a bit of data here. You can see we're going to set up an array foods that for the moment has one item, an object representing an apple. You'll notice the object has properties name, description, and source, where source is actually a path into our images folder targeting our apple image. We're also noting here that when we take a look at foods, the data that we set up in our Vue instances does not need to be restricted to simple types like our title or subtitle, for instance. Foods is in fact an array that then contains a complex object. That said, let's save our main.js file now and go back over to our index.html page, knowing this new data is available for us to render in some way. Making sure to stay inside of my div with ID the food app, since this is where my Vue instance is placed, I'm going to get a bit of space here starting on line 13, and then we're going to create a div related specifically to our apple. Pasting it in, you can see we're going to give it ID apple, and inside of it on line 14 we're going to output the name and the description of our food here, accessing the data the same as I would any regular JavaScript array containing object data. Foods element 0 gives me the first index in that array. We know that's our apple object, and then that has a name property and a description property that we're pulling out in rendering. So now that out of the way, what we want to do next is render an appropriate image for the apple, which we know our source property should point to. To do that, we're going to create an image tag here on line 15, and we're going to be binding its source property to our object's source property. Based on our highlighting here, you can see that this is accomplished by saying v-bind. This is Vue syntax for attribute binding, colon, and then the attribute we're trying to bind to. We want to bind to the image's source property, which is actually how you set an image in HTML. The right side of the equal sign is going to be an expression that should point to our value. So again, foods0.source. If we quickly look at main.js, just as a refresher, that's going to be a path to our apple.jpg. So really, that's all there is to attribute binding. We're going to make sure to use the appropriate syntax, v-bind colon, and then whatever the attribute name is. Making sure everything is saved. We've now set up some food information in our Vue instance, and we're attempting to render it out in our index.html page. So let's go over to the browser, refresh everything, and there you can see we're getting our apple's name, description, and our image. Now, before we wrap it up, I'm going to go back over to our editor here and show you that because attribute binding is a very common thing, and obviously we can bind to many more attributes than just the image's source attribute, there's actually a shorthand for attribute binding, which we're much more likely to see going forward. Basically, what it is we can just omit the v-bind, and the semicolon attribute acts as our binding syntax. If I were to save this, go back over to the browser, and refresh one more time, you can see that as expected, we're still getting that image, and our attribute binding is still working with the shorthand. In this video, we want to look at looping in Vue templates, which is a way we can easily render the same bit of a template many times, but each time we provided some different data to represent. Now, to see why this is a useful thing to be able to do, consider our app on screen here. Right now in our Vue instance, we've added some data, a key here foods, that as you can see on lines 6 through 12 is an array containing objects where each object represents a food item. So right now we have information for apple, banana, and eggs, so 3 food items. Now, over in our HTML, if we wanted to render out a div for each of those individual food items, and then basically output the data that we saw over in our Vue instance, one way to do that, the way we're doing things right now on lines 13 through 16, would be to render out the div individually per food item. So here you can see we're creating a div, giving it an ID of apple on line 13. And then within that div, to actually access the apple information, we're accessing it as the first element in our foods array. And from there, we're using dot notation to get the name, the description, and then its source property. If we wanted to continue using this approach, we'd probably just copy and paste our div 2 more times, and then update the index we were accessing, once for the banana and then another time for our eggs. In this particular case, it's okay because our array is relatively small, but you can see once we start getting more and more foods, this duplication of essentially the same template code is going to become much harder to maintain. To avoid that kind of thing, Vue gives us the v-for directive, which can loop through a list like an array and re-render the same template each time with a different array element in context. To see how it works, let's get rid of our div here on line 13, and in its place I'll paste in a new div. Within my actual div tag, you can see I'm going to assign this div a general class of food item, and then I'm using the v-for directive. Its syntax is v-for equals, and on the right side of the equal sign is an expression in the form alias in list. Looking specifically at what we have here, we're saying food in foods, where this final foods is our array, is the data structure we're going to loop through, and each time we do loop through it, each time we render this div, that next element in the array can be aliased within this div as food. So again, foods is our array and food is the alias name that we chose. I'm also binding to a key property here, which is a way for me to provide a unique identifier for each template I'm rendering. In my case, because I know all of my foods names are going to be unique, I'm going to say food.name. And typically in a real world application where the data you're rendering may be coming from a server or something of that nature, you're likely going to have an ID you can assign to this key. Continuing on now, like we said, our div and any other elements it nests are going to be rendered once for each element in the array, and food is going to represent each successive element. This means that within my div, I can access the properties of a food object via dot notation, so you see us here on line 14 saying food.name and also food.description, and below that on line 15, we're going to get our image path here by saying food.source to be able to bind that to our image. So that's really all there is to using v4. I'm going to go ahead and save this now. And now when the program runs, because I have 3 elements in my array, 3 food items, my div with this v4 should be rendered 3 times, and I should see all of that information, apple, banana, and eggs, being rendered out. Let's jump over to the browser now and refresh our application, and there you can see once it loads up, we're getting exactly what we expect to see. In this video, we want to look at conditionally rendering DOM elements in Vue based on custom conditions that we put into place based on our own business logic. To see how that works, consider our Vue instance here in a file main.js on screen. Right now, we're exposing some data here, and we want to look at the foods property, an array of objects where each object represents a food item. For the purposes of this demo, what we really want to pay attention to is that each food item here has a property %carbs that gives us an idea of how much of that overall food's composition is based on carbohydrates. So for apples, you can see it's 96%, bananas it's 93, eggs 2, and potato 53. With this data available to us, what we want to do is over in our template, over in our index.html file, we want to render out a different message in a paragraph tag depending on whether or not the particular food item is mostly carbs, moderately carbs, or not really made up of carbs at all. At the moment, we're already rendering out all of our food info here using a v4 block in a div spanning lines 14 to 18. So if we go ahead and jump in here, if we want to do some conditional rendering, I'm going to get a bit of space here on line 18, and I'll paste in a paragraph tag that's only going to be rendered if %carbs for this particular food item is greater than or equal to 80%. You can see us setting that functionality up using the v-if directive. So the syntax here is v-if equals sign, and on the right side here, we're going to set up an expression that needs to evaluate to true or false. If it's true, then this paragraph tag, or more generally, whatever element the v-if directive is added to, is going to be rendered into the DOM. If it's false, then this tag or set element is not going to be rendered at all. That said, in our specific case, if the food happens to be greater than or equal to 80% carbohydrates, we're just going to see a paragraph tag telling us this food is made up of mostly carbohydrates. Now, as you might have already guessed, we can also extend on the v-if directive here to handle other conditions or failing conditions just as easily as using v-if itself. Pasting in a few more lines here on lines 19 and 20, you can see I'm able to use a v-else-if directive and also the v-else directive. At this point, all of these directives are going to work together just as you would expect a regular if-else block to work in any other language. For our setup here, we're checking to see whether or not %carbs is greater than or equal to 40 and less than 80. So if it is, we're just going to say a significant portion of this food comes from carbs. And if none of our first 2 conditions are met, then the paragraph we're going to render out is just going to say this food is not at all a significant source of carbohydrates. So that's really all there is to it in terms of using v-if to render or not render. If we save this now and go over to the browser, once I refresh my application, you can see now for each of my food items, I'm getting that paragraph being rendered out. For our apple, which is mostly carbs, we get the appropriate message. Banana, also mostly carbs. And if we scroll down here to eggs, you can see the message this time is telling us that the food is not a significant source. And lastly, for potatoes here, we're seeing that a significant portion of this food does come from carbs. So that's using vif and its variants to conditionally render to the DOM. But before we end this video, we want to look at another Vue directive that has similar behavior to the I, but it actually works a little bit different behind the scenes. That's the Show Directive. To see how it works, going back to our main JavaScript file here, let's update our food data so that each food item now has a property is_fave. This is a boolean that's going to represent whether or not the user considers this food to be one of their favorites or not. As you can see, for each one of these, we're just going to hard code in some values now, making sure that some are true and some are false. Back over in our index.html file now, what we want to do is, for each food item, show a favorite icon that says star that's either going to be filled in or empty, depending on whether the food is a favorite or not. The star icon we're going to be using is provided by Font Awesome, so I'm just going to get some space here on line 6 in my head tag and add a link to that style sheet. After that, we're going to drop down into our body now, and we're going to update our template, basically to move our food name and our food description here into another div that we're giving class food title container. On line 17, you can see the name and the description have been moved into a span, and down below that on lines 18 and 19, we're setting up our favorite icon. Firstly, on line 18 here, we're going to display a filled-in Font Awesome star, and secondly, on line 19, we're displaying an empty Font Awesome star. Obviously, when we render out a food item, we don't want both of the stars showing up at the same time. We're only going to need one, depending on whether we're talking about a favorite food or not. And the way we're handling this in this instance is the vShow directive. You can see us using it on both lines 18 and 19, and the syntax here is v-show equal sign, where the expression on the right of the equal sign needs to evaluate a boolean, just like vif does. In our case, our expression on line 18 is saying if our food is a favorite, we're going to show this particular line, the filled in star, and on line 19, right below, we're basically just checking the opposite expression. If our food is not a favorite, then we're going to show the empty star. Now, the main difference between vShow and vif is that whilst vif renders a DOM element if true and removes that element from the DOM if false, vShow is going to render the element regardless, and it's going to use the CSS display property to either show or hide the element depending on the result of your Boolean expression. So keeping that in mind, let's save our index.html page, and before we go over to the browser and see all of this in action, I'll point out that I've added a new file here, styles.css, just to make our app look a bit cleaner. So in my index.html file, I'm going to need a link to that, which we're doing on line 7. Over in the browser now, if we refresh our application, you can see we get our new styling. Each of our food items is now in its own little box, and as well you can see right after the description for every food item we have a little star. Some of them are filled in, the banana and the eggs, so those can be considered favorites, whilst our potato and our apples are empty stars. Based on our explanation now, we know that this is being controlled by the vShow directive. So those are our options for conditional rendering and conditional display, and the one you go with is going to depend on your specific situation. For example, if some DOM that should be shown conditionally is either complex or expensive to render, and you expect that your app is going to need to show it or hide it a lot, then it might make sense to only render it once and then just show or hide it via CSS and vShow. In this video, we want to look at how we can bind to events and respond to when they occur in our Vue apps. Now, in our demo app on screen here, we've set things up so that it displays a list of foods from our Vue instance data. Each food item is either a favorite or not, as denoted by a filled in or empty star on that item's listing. So in this case, our apple, our potato, not favorites, while our banana and our eggs can be considered favorites. If we go back over to the editor now and look at our file main.js, at the moment we've only just hard-coded this favorite information into a property is_fave for each of our food items. Once the app runs and this value is rendered, there's really nowhere to change it after that. That said, what we want to look at doing is adding some functionality where at runtime, the user can actually click on the favorite star to edit whether or not they still like a particular food or not. Naturally, to do that, we're going to need to work with the click event, which really isn't an issue since Vue makes it pretty straightforward to work with events. In our index.html file, let's locate our favorite stars, which are on lines 18 and 19, our two spans respectively. In order to respond to clicks on either of these spans, I'm just going to update these lines by pasting in a new version here. And the only thing that we've changed here, the thing that's going to do the magic, is the v-on directive that we're using. As you can see, the syntax is v-on colon followed by the event we want to bind to, the event we want to listen for. In this case, in our demo, it's the click event, so we're going to say v-on colon click, and on the right side of the equal sign is what we want to do when the click occurs. Vue is flexible enough to let us perform simple assignment in this expression among a few other things. So in our example here in our template, when the user clicks the first star, the filled in star, what we're saying is we had a food that the user did like and now they are unfavoring, so our expression is simply going to access the food's isFav property and set it to false. One line below on line 19, if the user clicks an empty star, it means that the food that was previously not a favorite is now becoming a favorite. So similarly, we're going to access that isFav property, this time setting it to true, and you can see all of this happening right in the template. So it's that simple to bind to events in Vue. So making sure everything is saved now, let's go over to the browser, refresh our application, and now once it loads up, we have our defaults, our default favorites and unfavorites. But now that we should be able to respond to click events, if I click on a star here, you can see I get my filled in star, so I have responded to that event. If we test it out on a food that was a favorite, you can see we go to the empty star. So as simple as that, responding to click events in Vue. So now the one other thing we want to look at before we end this video is an alternative syntax for working with events. Let's jump back over to our index.html file now. And for the sake of the demo, let's handle something different. Let's handle when the user mouses over our food image. Our image tag is down on line 22, and we know that we should be able to handle that by saying v-on colon mouse over. But as I mentioned, we're going to look at an alternative syntax here, and pasting it in on line 22, you can see that syntax is simply at event. So here we're saying at mouse over, and after that it's the same as before, where on the right side of the equal sign we can handle that event and do whatever it is we need to do. In our case here, we're just going to log out to the console that we're over food here and then interpolate in that food's name. So saving this, let's again go back over to the browser, refresh the application, and this time let's pull up the console. And if all goes well, once I start hovering over these foods now, as you can see, we're getting that console output, so we can confirm that both of these event binding syntaxes are valid. In this video, we want to look at how we can define and use methods in Vue. Just like you would expect, Vue methods let us define reusable blocks of code that we can call to get some job done. Jumping right in, our app on screen here renders out a whole bunch of food items where each one tracks a property that determines whether the food is a favorite or not. Right now, when we click on the star here for each individual food items, you can see we're going to toggle the is a favorite or is not a favorite for that particular food item. If we go over to our Vue app now, we can start at the index.html page, where if I quickly highlight the code that's handling the click and the toggling of the favorite, you can see on lines 20 and 21 where we render out the stars, we're actually doing things inline in our template by on each click just updating the food's isFav property. So that's worked pretty well up to this point, since all we ever needed to do was modify the one property, and that could be done in a simple one-liner. In this video, however, requirements have changed. Now in our app, what we want to do is track the total number of favorites that the user has selected across all of the foods. To be able to do that, if we go over to our JavaScript file here, main.js, the one that's holding our Vue instance, I'll point out that we've added a new property here, favorites, to our app data. As you might guess, it's going to track the total number of favorites, and we're initializing it to 0 here on line 6. In addition to that, back over in our index.html file, in our template, if I were to highlight line 15 here, you'll see where we're going to render out a paragraph that's going to let us know the current value of favorites. With this setup, if we want to implement our running favorite total now, we acknowledge that when one of the stars are clicked, we now have two things to do. We still need to update the isFav property for that particular food item as we've been doing before, but now we also need to recount our favorites since something has changed, and we need to update this favorites property accordingly. What we're saying here is that in response to our click, this one-liner, the one-liner on lines 20 and 21, is no longer adequate, and our Vue method is going to be better suited to handle our needs. Methods are pretty simple to set up in Vue, so if we go back to our main.js file again, we're going to jump into our Vue instances options here, and we're going to add a new property, a new top-level property that we're going to call methods. Getting a bit of space, I'll paste that property in on line 14, where method is going to be an object where each key in the object represents a method name and each function represents a value that goes along with that method. Once we define these methods, we're going to be able to call them from elsewhere in the Vue app. In our case, if I were to expand out my methods object here, you can see we've defined one method, updateFavorite, which is a function that's going to take a name, the name of the food to be updated, and also a value, the value to update the isFav property for that food too. As we touched on earlier, in this method body, we're going to first search for the food in the list of foods. We're doing that here on line 17 using the lodash library to help us out. And if we find a matching food, we're storing it in a variable here, f, and as you can see on line 20, we're then going to update that food's isFavorite property using the value passed in to our method. The second thing we're going to do if we did have a match is loop through all of our foods after we've updated isFavorite and basically keep a running count of how many of them are favorites, so how many of them have the isFav property set to true. And once we have that running count, at the end of the loop, we're basically going to update our favorites property. So that's all there is to it. We've added the methods object and we've added one method where our method doesn't have any overly complex logic, but clearly it's more than a one-liner. With our method in place now, the last thing we need to do is go back over to our index.html file and make use of it. So right now, I'm going to grab both of my spans here, again my two stars, the filled one and the empty one, and I'm going to replace those to a version where instead of having the one-liner on click, we're calling our method updateFavorite both times, passing in the appropriate food's name, and in the case of a star that's filled, we're going to set the value or pass in a value of false to in effect make that food no longer a favorite, and in the case where the food was not a favorite, we're going to pass in true to make it a favorite. Saving this now. If we go over to the browser and refresh our application, you'll see we have our paragraph telling us how many favorites we have. It's initialized as 0, and we're going to disregard this for the moment because the way our app is set up, it's always going to be initialized as 0 on load, and nothing's really going to happen in terms of updating until we make some changes. If we do take a quick visual glance at the app though, you can see that bananas and eggs are considered favorites. They both have filled in stars, so if we attempt to maybe add apple by clicking on it here, as expected, Apple individually has had its favorites property updated, and as well our count has now been updated to have 3 overall favorites. Let's go ahead and add our potatoes in there. We go up to 4, and if we don't like bananas anymore, we come back down to 3. The Vue CLI gives us a command line executable that we can install and run on our development machines that then facilitates the creation of Vue apps. If we already know that the Vue app we're going to create is going to be a web app solely driven by Vue and the Vue instance, then the CLI is a really good choice to initialize an app and have a starting point. Using the CLI to create Vue projects gives us a trusted common starting point that contains project scaffolding, many default settings, and best practices already built in. All that said, even though there are sensible defaults in place, if we need to, we can still customize settings via a wizard at the point of a project's creation. So typically the Vue CLI is going to be installed on a development machine globally using npm or the Node Package Manager. Opening up a terminal on my development machine here, it's as easy as saying npm install -g at vue/CLI. In this command, it's the -g flag that's going to take care of installing Vue and its executable globally, making sure that it's available system-wide. Now, while that installs, one thing I'll point out over in my browser is that there is a later version, the one we just installed of the Vue CLI, and that's accessible via the package name at vue/CLI. There's also an older version of the Vue CLI, so unless you have a reason to grab this one specifically, you're going to want to make sure to avoid vue-CLI, since this is not the latest version and it's not the version we're going to be working with. Once the CLI has been installed in your system, you should then have access to the command vue. So if I were to say here vue-version, as you can see, I get some output here in my terminal telling me which version of Vue I currently have installed. Creating an app using the Vue CLI is a matter of using the Vue executable and its create flag. On screen here in our terminal at the lower right hand portion of the screen, what we're going to say is vue create followed by the name of the app that we want to create. For our demo here, we're going to call it the Vue Food app. Executing that command, you can see that the CLI provides for us a wizard to guide us through the app's creation. The first step, as you can see, is deciding if we need to configure our app beyond default settings. These default settings, the preset that's being suggested to us, is based on sensible defaults selected by the Vue team to provide you with an environment where you can just jump in and start focusing on your own business requirements. So that's definitely an option you have, but for the purposes of the demo, we're going to manually select features so we can go through this wizard. When we do our manual configuration, we're going to have to specifically select the features that we want for our project. In our case here, we're going to check Babel, and we're also going to check Linter to add those two features to our project. But as you can see, there's a lot more we can add right now at creation time. For instance, we can add support for TypeScript, allowing us to develop in that language. We can add support for progressive web apps if that's something we need to get done. And beyond that, we can add support for client-side routing in addition to state management via the Vuex package. If we needed to, we could go ahead and set up any CSS preprocessors we wanted to use, and the last two options here allow us to set up unit or end-to-end testing. Now, it's important to keep in mind that while the wizard does make it pretty easy to select any of these options to get us started, we can also add in any of these features at any point later on manually. So now, leaving our two features selected, I'll press enter to move on here. On the next screen, because we did say we wanted to add linting, we have to pick our linting setup. So I'm just going to go with ESLint and Airbnb and press enter again. And I want my linter to work on a lint on save kind of approach, so I'll select that. The next question here asks me where I prefer to place my config files for Babel, Post, CSS, ESLint, and any other config options. And you can see here, I can either put those in dedicated config files or package them in with my package.json. I'm going to leave in dedicated config files selected here. And if your custom setup is something that you know you're going to be using a lot based on your business environment or your own personal preferences, you can go ahead and actually create a new preset for those. I don't need to do that, so I'm going to press no and press enter. And now my project is going to be created based on my manual settings. Once the wizard is complete, as you can see along the upper left hand side of my screen here, I have a new folder that's been created, Vue Food App, and that's based on the name we passed in when we created our project. As well, as you can see, we're given some hints here, a few commands that we can actually use to go ahead and run this project right now. Basically, we need to switch into our project directory and then run the script here, npm run serve, which is a package.json script provided by the CLI, which basically starts up our project in development mode for us. If we do those two things, you can see our development server is started, which means that I should be able to go over to the browser now, port 8082 in my case, and you can see welcome to our new VueJS app. In this video, we want to take a closer look at the starting project we get when we create a Vue app using the Vue CLI. After having created the app, we haven't modified anything, and we've just run the script npm run serve, which builds and runs the app in a development context. The app that's run is what we're looking at on screen now. If we go back over to our editor, we want to take a closer look at the project structure and what we get when we create an app using the Vue CLI. To start off, let's go to our package.json file here on the top level. In it, I'll bring your attention to the scripts property on line 3 spanning lines 9, where, as you can see, we have 3 scripts that have been provided for us to use. Those are serve, build, and lint. Serve is what we're using now, what we just saw over in the browser, and what basically gets the development server up and running. Behind the scene, it's actually a Webpack-based development server, so we have all the typical Webpack configuration options available to us. Now, when we need a production-ready version of our application, we can use the build script instead. It's going to give us a version in an output folder that by default is called dist, and a version that's basically suitable for deploying. Lastly, the lint script gives us a chance to run our linter on demand. So for each of these 3 scripts, if we take a closer look, we'll notice that they're all making use of the Vue CLI service, which is a component of the CLI that's installed into our project as a development time dependency, and that provides a lot of core development features to help us as we go along. So that's the package.json. Next, what I'd like to show you is the public top-level folder that's provided by the CLI-based app. For this base project, we have 2 files provided, a favicon and also an index.html page. If we jump into the index.html page, you'll note that it's basically a typical HTML web page that we're starting off with. On lines 14 and 15 here is where we get an indication that the Vue app, when it's created, is actually going to get injected into this page in place of the div here, the one with ID app. The Vue-based app itself lives in the source folder, and so if we expand that out, you can see we have a file of interest here, main.js. Opening that up, in this file, main.js, is where our Vue instance is configured and created. We create it by importing and using the Vue constructor function, and when we use the constructor function, we're going to pass in a config object. In this case, as you can see, the only property we're setting here is render, and we're passing to that a function that's used to render our app. As you'll also note on line 7 here, the app that we're passing in is going to be imported from another file, app.vue, where the app that's being exported from there is a Vue component. We're going to look at that file shortly. This entire setup means that once the app is rendered, the starting point becomes the app component, and we're going to mount that component onto the DOM element referenced by the selector app. Again, back in our index.html, that's the div that we saw on line 14. Lastly now, let's jump into our file here, app.vue. Files that are suffixed with Vue, like this one, represent Vue components. They're a combination of template code, script code that drives the template, and then styling information to control how things look. So looking at this file, we recognize that it's not a typical file that your web browser would understand, and so it's Vue's job to break down this component file down into the typical parts that a browser would expect to see before things can get passed over, before your app can be rendered in the browser. Now that you've had a chance to get familiar with Vue, it's time to test out some of what you've learned. In this video, you'll initialize a Vue instance that mounts on a DOM element with ID app. Next, you're going to add your first and last names as data in the Vue instance. And after that, you're going to add 2 paragraphs to your index.html page, one with a welcome message and one with a goodbye message, both that use your full name. Once those things are in place, the last thing you're going to do is add a button to the app that when clicked, switches the app between displaying your welcome message and your goodbye message. Go ahead now, pause this video and give the exercise a try before returning to this video to see what a potential solution might look like. Creating the Vue instance has to do with using the Vue constructor function in the JavaScript file that drives your project and using it to create a new Vue instance via JavaScript's new keyword. When we do create the new Vue instance, we're passing to it a config object. To inject our app into an existing DOM element, we're going to pass in the L keyword EL to our config object as a property. The value we pass in here allows us to provide a CSS selector that can target the piece of DOM where we want to mount our app. In that case, it's going to be a div with ID app. To add some data to our app, we can add a data property to our options and then provide to that an object with data key value pairs. As you can see here, we're setting up first name and last name, both strings, and another variable here, say hi, a boolean initially set to false. Any data that's added here is available to be rendered to the DOM, so if we go to our index.html page, we can jump into our div with ID app here and create a few paragraphs where you'll note that each of them has their content being built up via interpolation. So in our first paragraph here, we're saying hi, first name, last name. This is our welcome message. And in our second paragraph, we're saying bye, first name, last name. So that's our goodbye message. Below our two paragraphs on line 14, we're adding a button that says click me, and you can see we're going to bind to the click event calling a method say something. Say something here references a custom method that we can see back in our main.js file under the methods property, which is how we add methods to our Vue instance. Expanding it out, you'll note here that the say something method is a function that when called basically toggles the value of say hi back and forth between true and false. Knowing that that's what the method does, we can actually go back to our index.html page now and note here that again on our two paragraphs on lines 12 and 13, we're using Vue's vif directive to hide one or the other of these paragraphs, so we're either hiding the welcome or the goodbye message depending on the value of say hi. To make sure this is working, we load it up in the browser, reload our page, and there you can see we start off with the goodbye message, and if we start clicking our button, we're going to toggle back and forth between our two messages. Components are reusable elements that we can create in Vue that encapsulate some functionality. Once created, we can use a component in our app as need be. In Vue, there's a few types of components we can use, namely global components and local components. Looking first at global components, we can create them using the component method exposed by the Vue object. So on screen here, to see how that works, we're going to start off in a file that we're calling my demo global component, and as you can see, it's a JavaScript file. In my index.html page, where I want to eventually use this global component, I'll point out that I'm importing our script file after I've imported Vue so that the Vue object is available to me in this JavaScript file. That said, in our demo global component file here, let's go ahead and paste in our global component. As we touched on, we're accessing that Vue object and we're calling the component method. To this method, we're passing firstly a string here, which represents a name for the component and which will also be the custom element that we're going to use to create an instance of the component in our template. Secondly, we're passing in a configuration object here, and if I were to expand that out, this configuration object is very similar to the type of configuration object that you would pass to the Vue instance when you create it. What that means is we're going to see many of the same properties on this object as we would see on the Vue instance object, so things like data and methods. You can see on line 2 here, we're actually defining the data property. And if I were to expand that out, you can see we're adding a few properties here, first name and last name. Our component also has a template property, which, as you'll note on line 9, allows us to pass in a string template that's going to be rendered whenever our component is used. In our example here, we're just going to render out a paragraph saying, hi, my name is, and then we use string interpolation to reach into our component's data and grab a first name and a last name. If I save this file, that's really all there is to creating and registering a global component. Once it has been registered, then it's actually going to be available for use throughout the entire app. To test that out, let's first go to our main.js JavaScript page here, where we're defining our Vue instance. You'll see here, we're going to target an element with ID, the food app, to mount this app. And if you go back to our index.html page, that's actually going to be our div here. What that means is my Vue instance is loaded within this div. So now within this div, I should be able to use my globally registered Vue component. As we touched on, the way to do that is via the custom selector we set up. So getting a bit of space here on line 13, I'm just going to paste in my demo global component. If I save this and make sure my app is running, I should now be able to go over to the browser, load up my app, and now in addition to all the other stuff that was previously rendered out on the page, above all of that, we have our global component being used. So that's setting up a simple global component, and as we said, because it's registered globally with the Vue instance, it can be used directly in the DOM as we've done here, or it can be used just as easily in any child elements or child components that we create. Now, in contrast to global components, we also have local components, which are components that are created and then registered explicitly where we want to use it. Once registered locally, the only place we can use the component is where it's been registered. To see a local component in action, we're going to refer to another JavaScript file that I've created here. This one is called myDemoLocalComponent.js. Again, you'll note that we are going to be loading this after we've loaded Vue and before our main.js file. Jumping into myDemoLocalComponent, on line 1 here, I'm going to paste in a constant that we're calling myDemoLocalComponent and is set to an object which, as you'll note, represents a configuration object for a component. You'll notice here we're not using the Vue component method, so there is no global registration taking place. The registration is going to happen where we need to use this component. So, for instance, if we wanted to use our component, myDemoLocalComponent, over in our main index.html page here, we know that means we're talking about using it in our overall Vue instance, which is set up in main.js. Going into that file now, I would then jump into my Vue instance, its configuration object, and because within here I know I want to use my demo local component, I'm going to register it locally by adding a components property which is set to an object. So we're setting this up on lines 33 through 35 here, and we use the key value pairs within this object to reference the components that we want to register locally. Whatever key you set is going to be the name of the component and also the custom selector you can use to access the component, and obviously the value is going to point to your configuration object. In our case here, because we're using ES6 notation, we're basically saying the key is my demo local component, and we know that the value points to the config object that we set up over in my demo local component.js. Saving this file, our demo local component is now registered locally with our Vue instance, so it can only be used within the Vue instance. In the same token, if I add another component where I wanted to use my demo local component as a part of it, before I can do that, I would need to register my demo local component with that other component in a similar fashion. With our file saved here now, this means that we should be able to go to our index.html and use our locally registered component. Getting a bit of space here on line 14, we paste in the component selector, and you'll notice here that we've actually used the kebab case version of our custom selector. This is an option we have, and using this kebab case version is going to work just as expected. Saving our index.html here, before we go over to the browser and verify that our local component does show up, I'll go back over to its JavaScript file and point out that in its data, we're setting up first name and last name as John Doe, just so it's something different from our global component. Back over in the browser now, if you refresh one more time, you'll note here the second line being rendered in our app here is definitely coming from that local component. So that's using local components, and before we wrap here, let's go back over to our editor and look at a few things with both of our components. For one, you'll note that the data property of both our local and global component is actually set to a function that when called returns the data object. This is a bit different from what happens on our Vue instance, and if we go to the main.js file here and look at its data property, you can see that it returns an object directly. In the case of the Vue instance, this works fine because we only expect to have one Vue instance at a time, but if we're talking about our components that we expect to reuse, if we did take this approach of providing only an object, then all instances of our component would actually be sharing that data, which is typically undesirable. To get around that in a component, data then becomes a function that when called can return a clean version of the data each and every time. Other than that, the last thing I want to point out is just some of the differences between global and local components. With global components, although it's much easier to use, they can become more error prone and vulnerable to things like name collisions, since basically everything is sharing the global namespace. If you do decide to use global components, you're going to have to be prepared to manage this as well, making sure to keep all of your names unique. Local components, on the other hand, can avoid this problem since they're not in the global namespace, but that said though, because you have to register them before they're available, if you have a component that you want to use in many places, like in many other components for instance, you'll find yourself having to require and register the same component repeatedly, which over time can start to feel like writing boilerplate code. In this video, we want to look at single file components in Vue. These are a kind of local component that comes with some valuable benefits. If you need to get up to speed on the differences between global and local components in Vue, check out the video titled Overview of Components in Vue. Jumping into it, we're in an app here that we've generated using the Vue CLI. it comes with a few things in place for us, one of which is an example single file component that's named hello world.vue. That's what's opened on screen right now, and although we're not going to be using this particular component, the thing I want to point out here is that single file components are files that have .vue as an extension. As you can see, hello world.vue is what we're talking about here. That said, to go ahead and get started, we're going to delete hello world.vue and in its place create our own single file component. It's going to represent the app's home page. So on the components folder, I'm going to right click, add a new file, and I'm going to give this new file a name here, homepage.vue. As a start in this file, I'm going to paste in an implementation on line 1, and then we're going to step through it. Doing that, right away, you can see that a single file component has 3 top-level HTML looking sections. Those are template, script, and style. The template section holds the template that this component will render when it's instantiated. The script section defines and exports the Vue configuration object that contains our logic and drives the template. And lastly, the style section, as I'm sure you probably deduced, allows us to style our component. So basically, in this one single file, we have everything we need to completely define the component, hence it being named a single file component. Expanding out our template here, we acknowledge that unlike other kinds of local components, the template for a single file component is not stored in a string. This means that we can get additional features and tooling like IntelliSense, error checking, and linting all at develop time, things that would have been lost to us working with templates that are stored in a string format. As you'll note here, at the moment, we're keeping our template fairly simple, where it's just a container div that contains an h1 with our app title and then a paragraph with our app description. Moving on, let's expand out our script section here on line 8. As we mentioned earlier, in this section, this is where we define and export the config object for this component. Components are similar to Vue instances, so again, a lot of the same properties that you might see get passed into a Vue instance, you're also going to see being passed into components, with the exception of properties like EL, since that one has to do with targeting DOM for mounting an app, which isn't something that a component typically has to worry about. In our app here, we're setting up 2 properties, name, which is a unique identifier that we can use later on to create instances of this component, and also data, a function that when called is going to return our data object. Lastly now, we have our style tag here starting on line 24. Expanding it out, we don't have anything in there at the moment, but as the app evolves, inside of this would be exactly the kind of CSS that you would see in a normal CSS file that's able to target and style our template. You'll also notice here the scoped attribute on our style selector, and when this is defined when it's present, it actually limits the scope of the CSS defined here to just this component only and no cascading to elsewhere. So at this point, with our very simple single file component in place and identifiable via the name homepage, let's see how we can use it. It's pretty simple actually. We know that given a Vue app created using the CLI, like this one, it's going to start off using the app component as its root component. If I then go to app.vue, you'll see that this file is actually set up in the same way as the single file component we just created. Although we didn't use it as our example of a single file component, that's exactly what it is. Since we know this particular single file component is the root component for our app, it's actually a very good place to use our homepage component. To get that done, all we have to do is import homepage from our homepage.vue file, which we'll get some space here and do on line 8. And once we've imported it, we're going to register it locally here by adding it to our components property. Next, now that it's available for use, all I have to do is drop it into my template wherever I want to render it. So we'll just drop it in here on line 3 inside of our app div. Saving this file, we should now be able to go over to the browser, localhost 8082 according to our dev server. Refresh the page just to make sure we have the most current version of our application, and there you can see we're getting our homepage component, which we know because we specifically set up this h1 with our title and this paragraph with our description. Child components are components that we use inside of other components. The concept is straightforward to understand, where the component being nested is the child component, and the component where it's being nested is the parent or host component. Vue apps are essentially a hierarchy of interrelated components, which means that this parent-child relationship is at the heart of it all. Having these relationships in place then allows us to start communicating between components to define business logic and build up our apps. To set up a custom child component here, we're going to start off in an app that's supposed to be all about foods. The app was generated using the Vue CLI, so we have a file app.vue created for us as a root component. We've also set up another component, homepage here, which we're using inside of our app.vue. Now, to continue to drive this app, let's say our business requirements wants us to be able to display a list of foods. In that case, we might consider creating a new component that's able to display information about a food and that we can reuse multiple times to generate a list. Naturally, to create that component, it's going to be a single file component, and for the demo here, we're going to call it food icon. To get a start on it, I'm going to right click on my components folder here, create a new file, and as we said, we're going to go with a name here, foodicon.vue. If we then jump into that file and paste in our implementation, we're going to start things off fairly basic. In our template, all we're going to define is a div here with class foodIcon, and that actually contains a nested div, one with class foodName, whose purpose is to display the name of the food. For the moment, we're just hard coding foodName into the paragraph. In our script section, in our config object that we're exporting, as you can see, all we're setting right now is a name property set to foodIcon so that we can create instances of this component later on via foodIcon. Lastly, in our style section, we're making sure to scope all of these styles to this component only, and you can see we've set up a bit of styling here targeting certain classes in our template. One for our container class, foodIcon, and then another here for our nested foodName class. So now, with a start in our custom foodIcon component, we can actually make use of it. As we said, our app aims to display a list of foods when it loads up, so we're going to be using our foodIcon component in the home page. To that end, we're going to go over to our homepage.vue single file component, jump into its script section on line 9, and import our foodIcon component before we drop down to our config object here and add a components property so we can register foodIcon. With that done, we want to make sure we can actually use our foodIcon component, so let's jump into the template, get a bit of space here in our food homepage container, and then go ahead and create a single instance of our foodIcon component here, nesting it in a div with class foodItems. From here, if we save everything now, go over to the browser and refresh our application, we should see it render with now our single foodIcon component being used. So this looks good, and as simple as this app is up to this point, we've actually already defined a few levels of parent-child component hierarchy. Our app component here is a parent to our homepage component, and our homepage component is going to be a parent to one or more foodIcon components. To continue on and make that happen though, the next thing we would think about is making the foodIcon component generic enough to be able to handle different food items, and then to actually generate a list of food icons from a set of actual food data. We're set up here in a Vue app, and what we want to look at is how we can pass data from parent components down to child components. The demo app on screen is going to help us see how we can get that done. And right now this app is set up in such a way where it has a home page component that on line 7 here is making use of a child component called foodIcon. At the moment, foodIcon renders out static information, but to make it more useful, it really should be set up as a generic component where we can pass in data about any food, and then the foodIcon component renders that data out. If we take a look at lines 21 through 25, we note here that our homepage component actually does have some food data that we can use set up in an array foods. Ideally, we'd be able to use this array to generate a certain number of foodIcon components, and for each one of those we'd pass in one of these food objects and let the component handle rendering that data. If we focus in on just one of our food objects here, you can see that each one of them is going to have a name, a description, and an image, where that image is coming from our assets folder for the time being. So that's homepage component. If we now go into what we currently have for our foodIcon component, I'll open up our file here, foodicon.vue, and as we touched on earlier, its template is very static, where every time we render out an instance at the moment, we're just going to get back this boring paragraph with a string food name. To go ahead and change that and set it up so that this component can accept more generic food objects, the first thing we're going to do is add a props key to this component's config object, getting a bit of space here on line 12. That key name is props, and for the moment we're going to set it up as an array with one string in it, name. With this setup, now whenever we create an instance of a food icon using its custom selector food icon, we can go ahead and add to that selector an attribute name set to a value, and then that name is going to become available to us in that component's instance. Because it is available to us, we can then use it in this component's template. That said, let's go back up to line 4 here, where we were hard coding in food name, and instead use the name value that's passed in. To test this out, let's make sure we save our food icon.vue here, go back over to our homepage component, and now where we were creating our one food icon instance on line 7, let's update it to pass in a name attribute. If we say name is equal to Apple and save this, we should now be able to go over to our browser, refresh our application, and now you can see when our food icon component loads up, instead of that hard-coded string food name, we're actually getting our apple, which is the value we passed in via props. So that looks good. Going back to the editor, now that we're comfortable with that, let's look again at our home page component. The next step now would be to use the actual data coming from our home page's component data, so again that foods array, rather than hard coding in a value when we pass name down to our child food icon component. Just so that we can compare and contrast the two instances, I'm not going to get rid of our original instance here, rather I'll get some space on line 8 and paste in a new food icon. And with this instance, you'll see we're using Vue's attribute binding syntax, :name, again when name is our property, to set name by reaching into the home component's data object, into that foods array, grabbing the first index, the one at object 0, and then accessing its name property via dot notation. With this setup now, let's save everything one more time, go back over to the browser, and if we reload the page one more time, now you can see we're getting our second component, and this one we know is being passed data coming from our home page's data object. Because of this, we're now fairly comfortable that we're able to use props to pass data from a parent component down to a child component, and then have the child component use that data, render out that data as expected. Given a Vue app that's making use of props and parent-child communication, often it's going to be important to be able to check and validate the props that are being passed to the child component before we actually try to use them. Incorrect data types or invalid values passed in as props can cause errors and/or unexpected behavior in our apps. Currently in the app on screen, our component food icon component is set up to receive an attribute called name when it's instantiated. In its template, we're rendering out name as though it's a string, but really we don't have any checks in place to make sure that's the case. As a start, one way to do some checking here is to use an alternative form of setting props, where instead of passing in an array of strings as we're doing on line 12, we're instead going to pass in props as an object where the keys represent the props we expect to receive and the values represent the types of those props. Pasting in that change, you can see in our specific example, we're talking about prop setup as an object with one key here, name, set to a value, which is a string type. With this setup, now if we try to pass in something other than a string, we're actually going to get a warning in the browser console letting us know that something is not quite right. Going back to my home page now, what I'll do is quickly set up a data object here, test set to a boolean true, and then we're going to go to our food icon component on line 7 and pass in name by binding to that value. If we save the application and go over to the browser, once it loads up, down in the console here you can see we're actually getting an error and it's telling us exactly what we expect to see. Prop type check failed for the prop name. We expected a string, but we actually got a boolean. So that's one approach we can take. Going back to the editor now, let's get rid of all this error checking code. And let's consider another scenario, which is what are we going to do if our component is expecting to receive a prop, but when an instance is created, it doesn't actually pass one in. So we can actually handle this in a few ways, and the first one we want to look at here is making a prop required. To do this is very simple. Going back into my food icon.vue file here, back to my component, what we're going to do is update our name key here to be an object instead of a string type directly. Pasting that object in, we see what that looks like. Again, our key is still name. This is still the prop we're expecting to receive. And now its value, the object here, has a type string, so we retain that type checking information. And now we've added a new property here to this object, required, set to true. With this setup, now if we attempt to create the component without passing in a value for our prop name, again we're going to see some warnings in the console. Let's save this, go back over to our home page, and delete the name on our first food icon here. If we reload the app this time, we're getting another warning here, where this time the message is different, telling us that we're missing a required prop, and we know that prop is name. So that's that, and if we jump back to the editor again, another option we have is to actually provide a default value in the event that none is passed in. To do that, over in my food icon component, I'm going to remove the required key, and in its place, set up another key here, default, set to a string value that should be used in the event none is provided by the component instance. If we save this, by now we should know the drill. We're going to go back to the browser, refresh the application, and this time once it loads up, we're not getting any errors, but instead here in our first food icon component, we're getting that default string that we set up, food name. So that's yet another approach, and one more thing we want to do here back in the browser before we wrap up this video is consider the situation where we expect the prop to be passed in, but we need to be able to validate that prop's value based on our own custom business logic. In this case, Vue actually allows us to set up a custom validation function that returns a boolean true or false based on whether we think the passed in prop is acceptable. To demo this, we're back in our food icon component, and down below my type setting string here, I'm going to get a bit of space. So now I'm on line 15 here, and I'm going to paste in my validation function. We're using ES6 syntax here, so the key we're setting is validator, and the value is going to be this function. As you'll see, the function is going to receive the value of the prop as n, and in its body, we're going to run our own custom business logic to return either true or false. For the purposes of the demo, we're going to say the value that's passed in needs to be logged in 3 characters, or else we consider it invalid. If we save our food icon now, let's go back to our homepage component one more time, and update our test food icon component here to pass in a name, where we're intentionally going to set this to a string that we know should be too short. Saving it and going back to the browser one last time, if we refresh the application and again look in the console, we can see we're getting a warning telling us that invalid prop because the custom validator check failed for the prop name. In this video, we want to look at how we can pass data from child components back up to their parent or host components. To get up to speed with the demo we're working with here, we note that it's an existing app that's all about displaying food. On screen we have our home page component, and as you can see on line 24 here, its data property exposes an array of foods. This is the food data that we want to display, and you'll note that for a particular food item, we're going to have properties like ID, name, description, image, and isFav. In our home pages component template, here spanning the lines 6 through 11, you'll note that we're using Vue's v4 directive and our array of food items to generate a number of food icon components, passing into them a food's name and also the food's isFav property. The food icon component we're talking about here is a custom component that's stored in our Vue file, foodicon.vue. We can see that in its props, it's basically set up to receive the same 2 values that we just saw being passed in, those being name and isFav, a boolean indicating whether or not this particular food item is considered a favorite one or not. The name property we're already rendering out in our template on line 4, but this isFav property we're not doing anything with at the moment. Knowing that this is going to tell us whether the food is a favorite or not, we're saying that we want to be able to display this in our app in a consistent way. So maybe we store our favorite functionality in a separate component and then make use of that component in our food icon component. That separate component, the one that's going to store our favorite functionality, we've actually already created in a file here that we're calling favorite widget. What we're saying here in the demo is that our favorite widget component here has a purpose that's threefold. 1, it should render out a star icon that indicates if the current item is a favorite or not. 2, it should also allow the user to click that icon and toggle the favorite value back and forth between true and false. And lastly, 3, it should be able to communicate to its parent component when it has been clicked, so that component can know that the favorite status has been updated. On screen, we have an implementation in place, so let's walk through it and see how it's set up. Down on line 20 here, we jump into the props for this favorite widget, and we can see here it's going to be able to accept some data from its parent. That's going to be an attribute initial value, and it's going to be a boolean, and when the component first renders, we're taking this initial value and using it to help us set a data property here of the component isFavorite. This value of isFav is then going to control whether we render a full star indicating that the food is a favorite or an empty star indicating that the food is not a favorite. Looking at our template from lines 3 through 8, we can see we set up 2 spans and we're using the Show Directive on each of those spans, evaluating whether or not we're dealing with a favorite or not a favorite, and then rendering one of our stars based on that. Our stars here are coming courtesy of the Font Awesome icon set. So that takes care of part 1, where the component is able to give a visual indication of its status. Next, we need to set up some functionality to allow the user to click the widget and toggle the favorite value. Again, looking at our template here, we note that everything is nested in a div, and we're using Vue's event binding syntax here at click to bind to click events on this div. When we do get a click event, we're calling a method toggle, and if we drop down to our methods property here, you can see that all toggle is doing at the moment is basically going back and forth, setting isFav to true or false. That's part 2 out of the way, but now to complete our requirements, we're going to need to set up a way for this component, a child component, to be able to pass data back to its parent component. The reason why we need to do this here, and why you'll need to pass data from child to parent in your own apps, all comes back down to the fact that components encapsulate their functionality, so even though a component is a child of another component, it doesn't mean the parent automatically knows what's going on with the child. In our case, even though favorite widgets go into food icon components, unless we explicitly tell the parent food icon that something has changed, it's not going to know that about the actual child, meaning that essentially it's not going to know that the user updated the favorite status of a food item. All that said, thankfully, passing data from child to parent is pretty easy thanks to the emit method provided by Vue. To see it in action, we're going to get a bit of space in our toggle method here starting on line 29, and we're just going to paste in a line that's going to say this.$emit. That's the method provided by Vue, and the first argument we pass to it is the name of the event we want to generate. We're calling that event toggle, and the second argument here is going to be some data that we want to pass along with this event to a parent component. In our case, we're passing the current value of isFav so the parent can know that, hey, this food is a favorite or it's not a favorite, but something has changed. So with this setup, I'll now save my favorite widget here, and we can say that this half of the battle looks good. The other half of the battle happens over in our parent component when we actually create a favorite widget. Jumping back into our food icon.vue here, we want to be able to create and use favorite widgets. To do that, naturally we're going to have to make a few updates. First, on line 11, we're going to import our favorite widget, and then down on line 25, we're going to register it locally for use in a food icon by passing it in to the components object. Once it's registered, we can actually use it, so down on line 3 here, we're going to paste in an instance of us creating a favorite widget. As you'll see here on line 4, when we create it, we're going to pass in an initial value based on the parent's version of isFav, so that's passing data to the child, and down on line 5 here is where we're able to receive data back from the child. Knowing that favorite widget internally is emitting an event called toggle, I can bind to that event by using Vue's vOn directive and saying here vOn::toggle, this toggle on the left side here being the name of the event generated by the child component. On the right side, we can decide what we want to do when that toggle event does fire, and here we're calling a method in our food icon component, also named title. Passing to it this $event means that within that method, we're able to get any data passed from the child component here in the parent component. All that's left to do now is to actually define this toggle method. So jumping down into my component script here, I'm going to get some space, set up a methods property, and in it, we're just adding one method toggle here that's going to receive a value, which we know is the data coming from the child component, the favorite widget component. Just so we can verify that, however, we're going to log it out to the console, and that's all there is to it. Saving our application as is, if we now go over to the browser, reload our application, and make sure the console window is opened, you can see we're starting off with our favorite widgets here in the upper left-hand corner of our various food icons. We know that those are set based on the initial data coming from our home page component, and because of how we've set up our favorite widget component, we expect that these are also clickable. If I do attempt to click one, you'll note that down in the console, we're getting that true/false output, which is basically our confirmation that we're successfully passing data from a child component back up to a parent component. In Vue, slots allows us to create especially generic and reusable components that can define their own templates, as well as an area for dynamic content to fill in when the component is used. We're going to be looking at how slots work in this demo, and so to get started, consider our food app on screen. We're looking at its home page component that right now displays information about a list of foods coming from its source data. On line 27, you can see the foods array, and each food object here basically has properties such as ID, name, description, image, is fave, and groups. In the template for a homepage component, we're generating a list of food icons using Vue's v4 directive to loop through our array of foods and basically passing in everything that a food object can pass in. So now let's say we're looking at our app, and at the moment we only have this one page, our home page, but we do expect to have many other pages as we continue to develop. The ideal for all of those pages would be for them to have a common format where they all have like a common header, common navigation, and a common footer, for instance, but where the main content then is able to change depending on exactly what kind of page it is. Slots make this kind of setup pretty simple to do. To try something out here, I'm going to create a new single file component in a file that I'm going to call pageWrapper.vue. Pasting in its implementation on line 1, let's step through what we're doing here. In the template for our page wrapper, we're defining our common areas that we just spoke about. The entire template is going to be wrapped in this class here, food app wrapper container, and the first thing you'll see in there is a common navigation bar. Beyond that, we have an H1 and an H2 on lines 8 and 9 that are set up to render out title and subtitle, where those are going to be consumed by our page wrapper as props. Down on line 13, we're defining a common generic footer area that again should show up on all pages using this page wrapper. Now, on lines 10 to 12 here is where we're setting up our dynamic content area using Vue's slot. Defining a slot like this basically allows us to set up a placeholder for our dynamic content. With this setup, now when we go ahead and create an instance of this page wrapper using its custom selector, food app page wrapper, any content that we place inside of the food page app wrapper's opening and closing tags gets slotted into place in our slot. That content can be any standard HTML and typical Vue template syntax. In your real-world application, exactly what that content is naturally is going to depend on the kind of page it is you're creating, the kind of page it is you're wrapping. So one thing to bring your attention to here on line 11 is that inside of our slot, we have a paragraph here that says default wrapped content. This paragraph is only ever going to get rendered out as a default if someone uses our page wrapper component but doesn't provide any dynamic content between its opening and closing tags. If they do, obviously we're going to use that content and the default falls back. So let's save this now and we have our page wrapper using a slot. If we go back to our home page, we should be able to update it a little bit to wrap its original content now with our brand new page wrapper component. To do that, we're first going to need to locally register our food app page wrapper component. So I'm going to import it on line 20 and then add it to the components property of my home page component. With that in place, I can then go to the template for our home page component, and in here what we'll do is define a usage of our food page wrapper. If you recall, our page wrapper does accept some inputs for title and subtitle, so we're going to be binding those to the title and description set up as data in our home page component. Now, at the moment our food app page wrapper is empty, you'll notice we're not passing in any content between its opening and closing tags, and before we actually try that, let's comment out our original content here. Save our application, go over to the browser and reload our application. Once it loads up, as you can see on screen, we have our page wrapper doing its thing. At the very top we have our nav bar, at the bottom we have our footer, the one that says the food app, and you'll also recognize our title and subtitle being passed in from the homepage component. Because we didn't add any dynamic content, we're getting the default wrap content, which is just what we expected to see. That said, this isn't all that interesting, so going back over to the editor, let's update our template one more time, and as you might have guessed, we're simply going to switch things up by now sliding our original content into our food app page wrapper's slot, minus the title and description. Remember, that's actually a part of the food app page wrapper now, saving everything. And if we go back over to the browser and refresh our application, now you can see when it loads up, we're getting our dynamic content being slotted in, so there you can see the homepage generated list of custom food icon components. Computed properties in Vue give us a way to keep our templates free from bloated expressions and overly complex logic, and also an opportunity to optimize performance in our app. In short, a computed property is a property whose value is computed or calculated based on some other value that it depends on. To try out a computed property in our app, we consider that it's a food app that displays info about foods. That info coming from our homepage component, the component we're looking at on screen right now, specifically its data object, which returns an array of foods. We then use that data to generate a certain amount of food icon components based on it. If we look more closely at one of the food objects in our data, we can see where it's going to expose properties about a specific food item, and the one I want to bring your attention to is the description property. It's a string that represents what the food is about, and so for each one of our foods, we have something appropriate. When I do create my food icon components, you'll note that it takes an input property description, so to pass that in, we're binding to our food's description. Continuing on now, if we jump into our food icon.vue here, what we're going to say is we want to modify this component a bit so that it displays a tooltip on hover. We're going to base the tooltip on the description of a particular food item, but at the same time, if we don't get a description passed in, we actually want to set up a custom backup string that the component can use as a tooltip instead. So one approach to getting that done is to create a computed property that addresses those both needs. Computed properties go into the computed configuration option of a component, where it's set up as an object with key value pairs, each key becoming the name of a computed property, and each value is set to a function that can compute the value of the computed property. Getting a bit of space in our existing component config here, I'm just going to generate that key. So again, that's going to be computed. And in it on line 49, we're going to set up one key value pair here, where the property name is tooltip, and the function you'll see returns a string that either uses the description property if it was passed in, but if not, it uses a default string that says no description provided. So now, once we've defined our computed property, we can refer to it in this template just as if it were normal data or props. Scrolling to the top of food icon component here, I'm going to jump into my surrounding div, the one with class food. This is a good place to locate our hover. I'm going to get some space here, and on line 3, we're going to set up a tooltip by binding to the div's title property, and as you can see, we're accessing our computed property, tooltip. When you do access your computed property, make sure you're not trying to call a method here. Remember, this is a key value pair we set up where the key is tooltip. Saving food icon component, that's really all there is to it, and what we can do now before we go over to the browser is quickly go back to our homepage component here, back into our food data, and I'll quickly just set my description for food number 2, the banana, to be undefined so that we can verify that our tooltip is generated as we expect. Let's save that, and let's go over to the browser. Refresh the application, and if things work as expected, if I now hover over any of my foods like apple for instance, as you can see on screen, our computed property appears to be working. We see the name and the description showing up there, and at the same time, I should also be able to hover over a food item that has no description, and there we have our confirmation the computed property also calculates as expected in that scenario. So that's a start at using computed properties, and at this moment you might be wondering why not just use a method instead of a computed property to generate our tooltip. Using a method would work, but then we lose one of the behind the scenes benefits of computed properties, which is its caching. Back in our component, when we set up our computed property here, Vue knows that this property basically has two dependencies, two variables it depends on, name and description. Based on that, Vue can calculate the value of our computed property once, cache the result, and then return that result whenever tooltip is needed. That said, Vue is only ever going to recompute the property, run this method, and incur the overhead of running it again if and when it detects one of the dependencies of our property, name or description in this case, have changed. On the other hand, if we use the method to calculate our tooltip, that method is going to be run each and every time, regardless. As they go through their lives, Vue instances fire a number of lifecycle hooks at various notable points that gives us a chance as developers to run our custom code at that moment. Since all Vue components are also Vue instances, this means that these same lifecycle hooks apply to our custom components as well. The Vue website currently on screen lays out all of the hooks clearly, along with when they occur in the lifecycle and what data related to the instance or components we can expect to be available at that point. At the moment, there are 8 lifecycle hooks, 4 of which are before hooks, meant to indicate something significant is about to happen, and the remaining 4 are the actual hooks, which are called when the thing has happened. So these hooks are before create and created, before mount and mounted, before update and updated, and lastly, before destroy and destroyed. Touching on each one very quickly, before create is the first hook that gets called, and it happens right after an instance has been initialized. At this point, things like data observation and reactivity have yet to be set up, so none of that is available to us. Created is up next, and this hook is going to be called after the instance has been created. Since it has been created, data observation and reactivity are now set up, so I can access things like data and methods. At this point, however, you still can't access the DOM though, because the component exists, but it hasn't been mounted yet. Before mount is called once our template has been compiled, and mounted is called after the instance or component has been mounted, and at this point we can basically fully interact with it. Next, before update is called whenever there are changes to data, and so the DOM needs to now be updated. This hook is a really good place to access the DOM, as it is, before an update occurs. The associated updated hook is called after the change has been made and the DOM has already been updated to reflect that. To round things out, when an instance is coming to the end of its life cycle, before destroy is called. The entire instance or component still functions completely, which makes this hook a very good candidate for any type of cleanup operations we need to perform. Lastly, destroy gets called after the Vue instance has been destroyed. At this point, directives have been unbound, listeners have been removed, and child components of the current component have also already been removed. So, those are the hooks available to us, and just to make sure they work as readily as they seem, over in the editor, let's try one out. The created hook is a good place to do things like fetch data from a server, or send something like telemetry data about a component to a server. Given our custom component on screen here, food icon component, let's imagine that for tracking and research purposes, we want to be notified each time a food icon is created. Well, if that's our requirement, then we might have a method defined in our food icon component that's able to handle sending telemetry events to our server. For the purposes of the demo, let's quickly set something up, and I'll jump into my methods property here and create a new method that we're calling log telemetry event. Its actual implementation isn't that important. All we're doing in it is logging something out to the console so we can verify that this is being called when we expect it to be called. With that in place, the next thing I need to do is actually use the created hook. To do so is fairly simple. Here in my components config, I'm going to get some space on line 19 and basically paste in a new key value pair here where the key is created and the value is a function that's going to be called by Vue at the appropriate point in our lifecycle. Just to be clear, we're using ES6 syntax here, so we're able to bundle in that key value pair setup into something simpler, allowing us to provide just this function with name created. In it, you can see we're going to use our log telemetry event method, passing in the name of our component. As an aside, I'm able to access the name property of my component by using this $options. Saving all of this now, let's go back over to the browser, refresh our application, and once it loads up and our 3 food icon components have been created, if I look down in the console, you can see we actually did send 3 telemetry events over to the server, indicating that our created lifecycle hook did kick in, it was called, and we were able to accomplish something at that point in the component's lifecycle. Now that you've had a chance to work with single file components and see how they communicate with one another, it's time to try out some of what you've learned. In this exercise, you will create a custom component that takes 2 props, first name and last name. Next, you're going to ensure that first name and last name are provided when the component is used. After that, you're going to add a method to your custom component that emits a welcome message to its parent component. And lastly, you're going to add an instance of your custom component to your Vue instance that is configured to listen for the welcome message. Go ahead now and pause this video at this point and give the exercise a try before continuing this video to see what a potential solution might look like. Creating a component that can accept input properties has to do with adding a props object to the component options. Each key value pair in this object represents an input that can be passed to the component when it's created. In our case, we've set up two such key value pairs, first name and last name. Making sure that the props have to be provided when the component is used means we should configure the specific properties by modifying their options to include a required property set to true. Emitting a message from a custom component can be done using Vue's emit method. In response to a button in our template here being clicked, we're going to call a method sendMessage that's defined down in our methods property. Within that method, you can see we're going to say this.emit to emit an event called welcome that also passes along with it a string data here, welcome, whatever first name is, whatever last name is. In our parent component, the app's Vue instance in this case, we can use our custom component, creating an instance of it via its name, my component, and making sure to pass in input properties first name and last name. We can also bind to the welcome event that this component emits, which we're doing on line 6, and once we receive the event, we're going to call the Vue instance's own method handle welcome, passing to it any event data. If we take a look at the handle welcome method defined in the Vue instance's methods property, you can see it receives any data from the event, and because we know it's a string in this case, we're just going to use it to set the value of this Vue instance's welcome data property. Going over to the browser now, once the app loads up, there you can see we have our custom component which only contains the one button, and if I click it, we see the message welcome Andy Alfred, meaning that we've communicated inputs into our custom component, and then the component has used those same inputs to emit an event and output back out to the parent component. Class and style bindings in Vue allow us to dynamically assign and reassign both classes and styles to our app elements at runtime according to the needs of the app at any moment in time. Let's start off here by looking first at class bindings using an object syntax. There's a few different approaches to implementing it in Vue, but we know that they all start by using Vue's binding syntax :class. In our first example on screen, the expression that we then provide is an object where the key is a class we want to conditionally apply, and the value evaluates to a boolean that determines whether the class is going to be added to this element or not. In this case here, since the boolean is hard-coded to true, the class active is always going to be on this div. So obviously hard-coding is not very dynamic, and you're actually much more likely to be setting your expression based on some variable defined in your component's script. In our second example here, active is set or unset based on the variable is active, where that variable is defined in our component's data. If we need to, we can also use object syntax to bind to multiple styles at once by simply adding more key value pairs to our object. As you can see in our third example, we're setting both isActive as well as a new class disabled, where again our component data is going to determine whether or not those classes are going to be added or not. I'll also point out that in certain situations where you may need to bind to many styles, adding classes in line, as in our third example here, might start to get a little hard to read in your template, and at that point you might just consider binding to a variable defined in your template where the variable itself is an object with all the classes that you need. Moving on now, another option we have for setting classes is by using an array syntax. In this approach, we bind to an array of data variables, where those same variables then point to classes that should be applied to our element. If we take a look at the example on screen, the resulting div here is going to have both the class active and disabled applied to it based on those being the values of active class and disabled class respectively. Shifting our focus now to style binding in Vue, it works in a familiar way to class binding. For example, in object syntax, this time the syntax is going to be :style, and we again provide an object. The keys in this object should be valid CSS style properties that make sense for the element, and as well their value should be appropriate for the style. In our example, the one style being set here for our div is its text color to red. As I'm sure you can guess, just like with classes, you're often not going to be hard coding a style like this, but rather providing a variable that resides in your component's data. In our second example, we're still setting our color here to red, but you can see now the actual color that's being set is stored in the danger color variable. Lastly now, just as we touched on with classes, oftentimes you're going to find that the most versatile and clean form of style binding is when you're going to bind directly to an object variable that resides in your script and whose job it is to provide one or more styles as appropriate. In our last example here, instead of adding all of these styles in line, which would become harder to read, we're just going to bind our style here to all styles, a data variable, and as you can see, all styles is able to then set those two CSS styles accordingly. We're set up here in a simple Vue app, and what we want to look at in this video is how we can use style binding in Vue. Our app is about displaying information on food items, and right now it uses a custom component, food icon component, to display an individual food item. When the app loads up, on screen you can see we have three such items: apple, banana, and eggs. Back over in the editor, if we look at our home page component, we can see on line 5 where we're creating our individual food icons. And at the time of creation, you can see each one is going to be passed a number of properties. The one we're interested in this demo is the image property. In my food icon component now, you'll see we're set up to receive image as an input props here. It's a type string. And in the event that we don't get one, we actually have a default here pointing to assets placeholder. This default image is coming from our public assets folder, which you can see on the left side of the interface. And if I expand it out, you'll recognize placeholder as the gray image with the question mark that we just saw over in the browser. By now, you'll also have noticed that the public assets folder also has a lot of other images where we're going to be using one of these to represent an appropriate food when available instead of the placeholder. So now, as you might expect, when we do create our list of foods as the app starts up, for each one, we're going to pass in an appropriate image, and then over in our food icon component, we want to use style binding to use that food's image instead of the default placeholder. Now, before we do set up our style binding, however, let's take a look at some of the default styles that we have set up on our food icon class. In its style section here, you can see we have a style food icon, where this style is going to target the class food icon that wraps our entire food icon div. Within there, again, you'll see the default background image is going to be set to placeholder.jpg. This is our save style, and we know this works because we've seen these placeholders in our app at runtime over in the browser. So to override this style with the dynamic inline image though, let's go up to our template section here, get some space on line 4, and then I'm going to use Vue's style binding syntax. That syntax is :style to bind to the style property, and we're setting that to an object here that represents styles that we want to set. In our case, that's background image, and you can see we're setting that by building up a URL using string interpolation and our image property. If we go ahead and save this, go back over to the browser and reload our application, now when it starts up, you can see that instead of placeholder images, we've used Vue's style binding to actually set appropriate images for our food items. So that's getting a start with style binding, but before we wrap it up, let's go back over to the editor one more time and modify our app a bit to use a common pattern where instead of defining our inline style explicitly in our template as we're doing on line 4 here, we're going to define and use a computed property that returns the style object. To do that, on line 18, let's expand out our component's config object. Let's go into the computed section, and here you can see we're going to create a new computed property that we're calling generate food icon style, and as expected, it's just going to return an object with the same background image styling that we just set up earlier. Once this is in place, I can use this now as a computed property in my template, as opposed to directly setting my style in line. Saving this, if we go back to the browser and refresh one more time, we can confirm that our style binding in Vue still works as expected. We're set up here in a Vue app, and we want to look at how we can use class binding to dynamically add classes to our Vue components as need be. To help us see how to do this, our demo app here displays a list of food items, each one via a custom component called food icon component. When these components are generated, they're going to be passed in a number of input properties, and for this demo, the one we're interested in is the group property. You can see we're binding to group here, passing in f.group, where f is basically an instance of an object that has properties about a specific food item. If we jump into our custom food icon class here, we can see in its input props, we're receiving all of the properties we just saw being passed in from the home page, but the one we're interested in again is group, and in science, since every food group belongs to one of 5 valid groups, fruits, vegetables, grains, meats, or dairy, we're running that input that's passed to this component through our validator just to make sure we're not getting garbage in. So now, given our food icon component, the goal here is to make our app more visually informative, so we want to add a custom class to each food icon instance, where that class is going to be generated based on its particular food group. The classes that we do generate and add to our food icon are going to then be targeted by CSS styling that does things a bit differently depending on the food group. If in our food icon component here, we scroll down to the style section, you'll see on lines 95 through 113, we have a number of classes set up. They all start off food-group, but then you can see they get more specific, one for fruits, one for vegetables, and so on. And as you'll note, each of these classes here is going to set a border left that's going to be 5 pixels thick, solid, but then the color that's going to be set for the border depends on the particular food group we're dealing with. With all of this in place now, let's scroll back up to the template section of our food icon component, and what we want to do is use Vue's class binding syntax to bind to a dynamically generated class name. I'm going to get a bit of space here on line 5 and do that. So you see here again saying :class, and the classes we're going to be adding here, we're going to pass in as a string where it starts off as food group, and then based on the group that's passed into our food icon component, we complete this class string. Saving all of this now. If we pop over to the browser and refresh our application, once it loads up, now you can see, as expected, we're getting that border along the left side, and the color of the border is going to depend on the food group. So apple and banana are fruits. They get the same color, while eggs as dairy here gets the color blue. So that's a pretty good start to class binding. And now that we're sure this works, back over in our editor, the next thing we might consider doing is moving our dynamic class creation away from the current inline template setup and into a computed property. While we're at that though, in addition to setting up left borders for our individual food groups, we also want to add some generic styling that's going to be the same for each of our groups. Scrolling back down to my style section here, we're going to set up another style. This one we're calling food group, and you can see when it's applied to any class, it's just going to add a bottom right box shadow that's 5 pixels thick and that's a little off-white. So now, going back up to our template, we want to apply this food group class to our food icon div. So we're going to do that in our computed property, as well as still handling the generation of our border classes. Now, to get all of that set up, I'm going to jump into my component object here, into the computed property, and at the bottom of my previously existing computed properties tooltip and generate food icon style, I'm going to get a bit of space and add in a third one, and this computed property function here we're calling generate food icon classes. In it, we're going to create and return an object where the key value pairs in this object have keys that represent the classes that can be added dynamically, and the values evaluated true or false, which determines whether or not the class is actually going to be added at that time. Having an object that we can configure and return like this gives us a chance to conditionally apply classes based on our own business requirements. In our case, you can see we're going to create classes as our empty object to start off, and we're returning classes, and in the middle here, since we know we want to set the classes food group and then food group dash whatever the specific group is, we're going to add both of those to our object here, and for both of those we're going to return true. Once that's done, I can take my computed property, go back up to my template now, and where we were binding to a style that we were setting in line, I can instead just go ahead and bind to this computed property. It's going to return the object with the classes, and then the classes are going to be applied. That's all there is to it. Let's save this, and now if we were to go back over to the browser and refresh our application one more time, as expected, we still have our different colored left borders, but now you can see we also have our box shadow being applied to each food icon component. CSS preprocessors give us a way to write more manageable CSS. They extend the kinds of things we can do in CSS and the ways we can write CSS, and at the end of the day, the processor boils it all down to regular old CSS that a browser can understand. It's called a preprocessor because the compilation is going to happen before the CSS and its web page are delivered to the browser. Now, using CSS preprocessing in a Vue app is pretty simple to set up, so we're going to look at how we can do that in this video. Before we jump into that, however, I'll point out that the app we're working with was generated initially using the Vue CLI, and as part of that initial creation, we did have the option to add a CSS preprocessor. We didn't do so at the time, but if you want to see how that CLI wizard looks, you can refer to the video entitled Creating Projects Using the Vue CLI. Here in this video, we're going to look at how we can manually set up support for CSS preprocessing in our Vue app. It all starts with installing a few Node modules, namely Node Sass and Sass Loader. I can install both of the modules I need via npm. So down in my console, I'm going to say npm install save dev node sass sass loader. Sass Loader helps Vue single file components work with Sass, and Node Sass is a Node module that gives us the ability to compile the Sass files we write. Once they're both installed, I can then go into a Vue single file component where I'd like to use something like SCSS, and in its script tag to enable SCSS, I'm just going to add an attribute here, lang, short for language, and we're going to set it to SCSS. That's pretty much all there is to it, so at this point going forward, I can now use SCSS-based styling syntax for this component. Of course, I don't have to change anything because valid CSS is also valid SCSS, but to try this out, let's define a variable here that can help us standardize the style that defines the left border we're applying to much of our food group divs. Scrolling down a bit in my food icon component, you'll see we have a number of food group styles here, such as food group fruits, vegetables, dairy, meats, and grains, where the style being set in each of them is a border left that has the same width and also the same pattern as in solid. What we're going to do is define a variable to help us centralize this width and pattern. I'll just scroll to the top of this style section, and I'm going to call that variable here $food group highlight border, and we're going to set that to a 5-pixel solid black border. With that in place, I can use it down in my food group classes that we just looked at, subbing it in for each of the individual values, and then the only thing I'd have to set that's specific to each group here is the border color. So this looks good. All we need to do now is save our application, and if we go back over to the browser and refresh it, if everything works as expected, we really shouldn't see any change to our front end here, and as you can see, this looks good. We're still seeing our borders, even though behind the scenes, we're now using a CSS preprocessor to help us set up those borders. Client-side routing is a common component in web apps like Vue that comes into play once our apps start to grow in complexity. In this video, let's look at setting up client-side routing in our Vue app. The app we're working with was generated using the Vue CLI, and as part of its initial creation, we did have the option to set up routing at that time. We chose not to back then, but to see how that wizard looks, you can refer to the video entitled Creating Projects Using the Vue CLI. Since we did not use the wizard, we're going to be manually installing routing into a Vue app, and that starts with installing the Vue router. In my terminal, I'm going to be able to run the command npm install vue-router --save to complete that process. Once npm has done its thing, I can verify that the Vue router is installed by checking my app's package.json file, where in my dependencies object, I should now have a reference to the Vue router. Next, we can start to define some routes in our app. Before we do that though, let's go over to the browser where our app is running and take a look at its current state. You'll know that once the app loads up on its home page, it's basically displaying a high-level summary of all the food items that it maintains. Specifically, for each food item, we're going to show a name, an image, and on hover here, we're also going to show a tooltip with a description. What we want to do is take this app to the next level now and provide a more detailed view for an individual food item if the user clicks on one of them at runtime. This kind of requirement is where routing can come into play, where we want to set things up so we can route from this high-level page view to a more detailed page view on demand. Back over in the editor now, what we need to do is to actually set up a component to represent our more detailed view, since at the moment we don't have one. We're going to create it as a single file component, so I'm going to right click on my components folder, create a new file, and we're going to give it a name here of food_detail_page.vue. Once the file opens up, let's just go ahead and set up the minimum that a Vue single file component needs for right now. In the template section here, we're just going to create one div that says food details. And on the script section on line 5, if I expand that out, we're just going to export our component configuration here that for now just contains a name for the component, and we're calling it food detail page. If I go ahead and save this, at this point we now have two page level components, so we can set up routing from master to detail views as we discussed earlier. To recap, we want to be able to route from the home page to a details page as part of how our app flow works. Routing in Vue works by defining routes, which are mappings between URLs and our Vue components. At runtime in the browser, if we have a particular URL in the address bar, it means that we should be seeing its associated component being rendered on screen. To go ahead and set up some routes, let's create a new folder here that we're going to call router in our source folder. So I'm going to right click, create a new folder, give it a name router, and inside of that folder I'm going to create a JavaScript file here that I'm going to call index.js. Inside of index.js is where we're going to be defining some routes. The first thing I want to do here is, on line 1, import the Vue object and also the Vue router, in addition to any components that we want to be able to route to. In our app, those components are obviously going to be the homepage component and the food detail component. Next, we're going to tell our app to use routing by saying vue.useRouter, and after this, we're going to create and export our router. We can create the router by using the router object as a constructor, so we're saying new router here, and we're passing to it a configuration object. If I expand it out, the configuration object contains a property routes, which as you can see is an array of routes. We only have 2 routes in here at the moment, but if we take a look at them, you'll note that each route is basically an object with 3 properties: name, path, and component. The name property allows us to refer to this route elsewhere in our application, whereas the path represents the URL or pattern that Vue is going to look for in the browser's address bar. Whenever that pattern is present, the associated component for a particular route is then what's going to be rendered on screen. So again, in our case, whenever the browser bar contains an address here or URL that says /food details, we're going to be rendering the food detail component on screen. As your app grows, you're going to find yourself often modifying this file to add new routes as you add new features to be able to navigate around the app effectively. So at this point, we've created a router and we've defined some routes. The next thing we would think about is seeing how we can actually use them in our app. We're set up here in a Vue app that we've configured for routing, and then we've gone on to define a few routes that can allow us to go from the home page of our application, a component with name homepage, to a more specific food detail page, that one being represented by a component with name food detail. With these routes defined and available, in this video we want to look at how we can actually use them to drive navigation around our app. The way things are set up now, no routing is actually taking place. If we look in our app component, app.vue, we know that inside our template on line 3, when the app loads up, we're actually just directly creating an instance of our homepage component. We want to move away from this approach and move towards using routes to define what's being rendered. That said, to get started on this, we're going to remove our homepage component from being hard-coded into our app view template. And since we don't need it anymore, we're going to also remove the import for our homepage component, along with our local registration of that component. That out of the way, now when the app loads up, we're not going to see anything because our template just contains the empty div here. To set up routing, we need to provide a place in our template where the components that match the current URL can be rendered. We're going to be able to indicate that place using Vue's router view directive. Getting a bit of space on line 3 here, I'm going to paste in the router view directive, which as you can see is router-view. And you'll note here that we're dropping this in place of where our hard-coded homepage component was. We're looking good so far, and moving on, now that we have a place for our routed views to call home, The next step to take is to pass our configured router to our Vue instance. You'll remember that we did configure our router over in our index.js file here, where we newed up an instance of a router, passed it our config object with our own custom routes, and then we exported that instance. To make use of this, I'm going to go over to my main.js file, import that router here on line 3, and then where I'm creating my Vue instance, I'm going to be able to pass that router in as a property. If I now go ahead and save this, at this point, everything is set up, and so I should be able to go over to the browser where my app is running, reload the application, and if routing is working the way I expect, I should be able to type in a URL that matches a particular path that we created in our routing file. So to test that out, let's type in at the end of our domain URL here, food/details. And once we do navigate there, you can see we're taken to the very basic skeleton of our food details page. At the moment in our application, the only other route we had set up was the empty route, so just /. So if I go ahead and delete all of this stuff and just enter in a / here, that should actually take me back to the home page, which is exactly what we see happening. Before we wrap here, one thing I'll point out is the presence of the hash mark in our URL. By default, this shows up as an indication that the router is in hash mode, where we're basically matching client-side routes after the hash. This prevents the browser from making requests to the server and reloading when the URL changes. That said though, we do also have the option of using another mode called history mode, where our routes look more like normal routes. However, in that case, we have to make sure our servers are set up to handle requests meant for the client side that might end up coming to them if a user types in the client-side URL directly. The way to handle this server side is typically by adding a catch-all that returns the app's index.html page instead of a 404 if a request comes into the server for some resource that it does not have or understand. We're set up here in a Vue app where we want to look at using router links to help us set up click-based client-side routing. At the moment, this app does have a few routes set up where we can see the app's homepage component via the empty path /, and additionally, we can go to another skeleton page for displaying food details via the path /food details. The broad strokes of what we're going to be doing in this demo is building out a few more skeleton page components, one for an about page and also one for a favorites page, and then we're going to make all of these accessible via a navigation bar so our app users are not required to manually type in URLs. To get started now, let's quickly set up our page components. Clicking on the components folder here, I'm going to say new file, and our first component here is going to be named about page. And then we can repeat the same thing to create our second component, so new file, and this is going to be our favorites page. Inside of our two new single file components, we're not going to be doing too much other than setting up a basic skeleton at the moment and making sure we're using our app's page wrapper component to wrap the page's content. Pasting in a bit of a skeleton for both, we can see what we're talking about. Our favorites page component has a name favorites page, our about page component has a name about page, and in both of them, we're just going to import the food app page wrapper and use it to wrap the page's content. This will do for now, so let's go ahead and save both of them, and then we can continue on. With our new page components in place, let's go over to our existing routing file and set up some routes so that we can route to each of these components. I'll just go back to a single page view here, bring back my Explorer, and now we're looking to go to router index.js. On line 6, I'll get a bit of space and import our two new page components, and then we'll just drop into our routes array and create some new routes for each of those components. So the path /about is going to route us to about page component, and the path here /favorites is going to take us to our favorites page component. You'll note we've also given the favorites page component a name of favorites and the about page component a name of about. Let's save this file now, and now that we have our new routes set up, we want to add them to our app's navigation bar. The navigation bar is a common part of our app, so we've already set it up in our page wrapper component, and if I were to open up that page wrapper component, you'll see on lines 3 through 7 the initial skeleton for our navigation bar. At the moment, it's using a series of anchor tags with no target. This was just our skeleton nav bar, but we're now going to get rid of these and instead use Vue's router link component. Selecting each of my A tags here, I can replace them with router-link, and then I can actually get rid of all my hrefs. At the same time here, we don't have a meals page, so let's change that to our about page. And now we have a start to setting up a few router links. For each of these router links, we can set a target, a place that we route to by using the to attribute. There's a few ways we can set the to property. So in the case of our home router link here, we're going to set to equal to a string directly, where the string we provide needs to match a path defined in our routing file. In this case, we know that the path / maps to our home page component. Another way we can set to is to bind to a route object. So for our favorites, we're going to do that where I say to is equal to an object, making sure to add the semicolon before to indicate a binding here, and the object needs to have a name property where the name matches a route that we have already set up. The name favorites is going to match the route here that we've given the name of favorites. Back over in our page wrapper now, the only other router link we're using is the about link, so let's go ahead and quickly map with the string here pointing to /about. Let's go ahead and save our page wrapper now, and this is basically our setup using Vue's router link component. To test this out, let's go over to the browser, refresh the application, and once it loads up, we can see our updated navigation bar with our links here, home, favorites, and about. We're already on the home page as indicated by the / in the URL, so let's attempt to go to the favorites page by clicking on our favorites link. And as expected, we end up on that page. The about page should work in a similar way, so that looks good, and at any point we should be able to navigate back to the home page by a simple click. Before we wrap though, let's go back to our editor, where I'll point out that one of the benefits of using the router link component as opposed to just using a tags directly is that the router link component automatically manages adding and removing certain CSS classes based on which route is active at the moment. By default, when the router link is clicked and it's active, that router link is going to have a class added to it, router link active, which gives us a chance to style that to convey more information to our users. That said, our router links are defined in page wrapper, so let's attempt to style the active one by dropping down into our style section here and adding a new style that targets the class router link active to basically set a background color of white and a color of black here. I'm going to go ahead and save this, but before we check it out in the browser, we're going to go back up to our template and we're going to add one more property to our router links, which is the exact property. We're adding this property because by default, the adding and removing of the router link active class is inclusive, which means that URLs like our home path URL here, just the / is always going to be considered active for styling, since essentially every route includes the /. Since in our app we don't want this behavior where the home page always looks active, we're going to add this exact property, which means that the path should be matched exactly, not inclusively, when considering the active class. Again, let's save everything, and one more time, let's return to the browser, reload our application, and once it loads up, now you can see we're on the home page and the router link for the home page is clearly active. If I attempt to go to favorites or about, you can see where we can easily get that styling, convey this information to our users by taking advantage of the exact property and also Vue's router link active class. In this video, we want to look at setting up programmatic routing in a Vue app. The app we're working with at the moment displays a list of food items on its home page, and so we want to allow our users to be able to click on one of these individual food items and end up on a detail page for the specific item. Right now on screen, we're looking at the app running in the browser, and we just have 3 food items here. And so if we click on any one of those, you'll notice that nothing is happening right now, but the point here is to add programmatic routing that allows us to go from this overall page to a detail page based on clicking one of these individual food items. If we switch over to our editor and we take a look at our app's home page component, I'll bring your attention to its data property, which exposes the variable foods here, which is the source data for each of our food items that we're seeing generated. For every individual food item, we have a property here, nutrition data, so you can see if I scroll that into view, for our 3 food items we have the same property, nutrition data, and expanding out just one, this kind of information has a very good candidate for showing up on our details page once a food item is clicked. If we scroll further up in the single page component and look at the template, you'll see that when we generate our food icons here, we're doing so using a custom food icon component, and at the moment, it's not really clickable. One way to change that is to bind to the click event for each of these food icons, And so getting some space here on line 5, I'm going to paste that in so you can see we're going to say at click to bind to the click event, and when that occurs, we're going to be calling a method show details. Naturally, we now need to make sure that this method is defined, so let's jump into our script section for our homepage component here. Add a methods property, and in it, define the show details method. Expanding that method out, as we touched on, it gives us a chance to respawn when our food icon is clicked. We can do anything we need to do in here, but really, obviously, what's important for us is programmatic routing. In Vue, to route programmatically in this method, we know that we do have access to the Vue router via this.$router, and its push method allows us to actually route elsewhere in our application. When we call the method, we're passing in a string here /food details, where this path is going to match a path that we have set up in our routing file and is associated with the component that should be rendered. So at this point, this is the most basic demonstration of programmatic routing right now, but before we continue, let's make sure this works by saving everything, going back over to the browser, reloading the application, and once it loads up, we expect now that we should be able to click any of our individual food icons and end up on the detail page. So performing a few clicks here, we know that we're not actually seeing that happen. So this might seem odd, but the way our app is set up right now, this is actually expected behavior. Back over to the editor again. In Vue, when we bind to events the way we're doing on line 5 here, Vue is only going to run our binding logic if the event is generated via an emission from the component it's on. Another way to say that is that Vue by default responds only to events generated by Vue. In our case here, we're actually interested in the native DOM click event, but since this event isn't generated via Vue, it's being ignored. If inside of our food icon component, we explicitly emitted an event named click using the $emit method from Vue, then this show details this binding would fire. If you're interested in learning more about custom Vue events, you can check out the title Handling Events. That said though, in our case here, if we do want to listen to native events like native DOM clicks, then what we can do is modify our binding a bit, in this case to add the native modifier. Adding the modifier is as simple as saying @click.native, and just like that, we're able to listen for native clicks. Let's save this one more time, go back over to the browser, refresh our application one more time as well, and if this all works as expected, now when I click on any of my individual food icons, you can see I'm ending up on a custom food details page. So at this point, we're in a good place as far as programmatic routing is concerned, but as you can see, our food details page is a bit bare. At the beginning of the video, we did look at all our extra nutrition data that would be appropriate to show on this page, so the next step would be to continue getting that set up. And to get that done, one approach we might consider is passing some additional information when we do perform this programmatic routing. We're set up here in a Vue app, and we want to look at how we can use route parameters. Route params allow us to map parts to components, where the parts are able to have a dynamic portion, a parameter portion that conveys some additional information to the target component. To see how it all works, let's consider our app. Right now we have a homepage component, the component we're looking at on screen, that displays a list of food items in the grid. When we click on an individual food icon here, we're responding by calling a method show details, and our intention in that method is to route to another component, the food details component, since this component is ideally suited to display more in-depth information for a single food item. As you can see on line 94 in our homepage component, this routing is already set up, where we respond to the click, call our show details method, and we're using this.router.push to go over to the food details page. The issue with this current setup though is when we do get to the food details page, how do we know which food item we should be displaying details for? Using Vue's route parameters is one approach we can use to pass along some additional information when we do navigate the food details that food details can then act on. So now, going to our router file index.js here, let's see how we can define route parameters on our food details route. We can see that route being defined here on lines 20 through 23, where we're going to map /food details to the food detail component. To modify this a bit, we can define a route param on this route by saying : param name at the end of the path. In our case, we're going to call the parameter name, so we're going to end up with :name. Saving this, at runtime now, if we see a route like food details /apple or food details /banana, we're still going to render out the food detail component, and in that component, the parameter value apple or banana is going to be accessible to us. That said, now that our route can't handle a parameter, we can go back to where we were navigating to our food details page, and that's in our home page component here, in its template where we were calling the show details method. When we respond to clicks, we can actually call this method and pass data to it. So for each individual food item, let's go ahead and call show details and pass in the food's name. That's going to be available as f.name here. So once that's set up, we now need to scroll down to our methods property to where we define show details and get it set up to actually receive a name. Inside of the method body, now that we have a name, as you might expect, we're going to use it as our route parameter by simply appending it to the end of the path we're navigating to. So now, at this point, when an individual food item is clicked, we're going to navigate to food details, passing along some extra information on our route as a route parameter. Beyond this though, we still need to actually use this information in some way, so let's go over to our food detail component and see how we can access our dynamic route parameter. Opening up food detail page.vue, at the moment you can see it's quite bare. So to get started, because we know our route parameter is called name, let's define a new computed property, food name, that we can calculate by accessing our route. Pasting that in on line 10, we're going to do that by simply saying this.$route.params.name. So that looks good, and now that food name is in place based on our dynamic route parameter name, we're then going to define yet another computed property called page subtitle that we're going to return as a string specific to our food name, assuming it was set up without issue. We're going to paste that in starting on line 13 here. And as you can see, this string is going to be built up using our food name property, which itself is using our route parameter name. Lastly here now, with our page subtitle being set up, we can render that out somewhere in our food detail pages template. To do that, we're going to update the template a bit to wrap all of the page content in a food page wrapper component, and then we're going to set the wrapper's subtitle. First and foremost, I need to import my food app page wrapper here, and then register it for use locally. And once that's done, we're going to get rid of this div in our template and instead use the food app page wrapper. At the moment, we're not wrapping much content, but you can see where we are going to bind to our food app page wrapper's subtitle property with our computed page subtitle. Let's save everything now and go over to the browser. And once we reload our application, if all of this works as we might expect, we should be able to now click on any of these individual food icons on our home page, causing our food details page to render, and its subtitle should clearly let us know more about the particular food that was clicked. This does look like the behavior we're getting here, and I'll also point out too that when we do route to our food details page, you'll also be able to verify the exact route as it's going to be updated in the browser bar to reflect a particular food's name. When we use routing in Vue, we know that we can define route params that allow us to pass along some extra information to our components as part of the URL. In addition to that though, we can actually pass more complex data as route params, which can come in handy in certain scenarios. In our current app, the one on screen here, we're going to look at passing objects along as route parameters. The way this app is set up currently, when a user clicks on a food icon on our home page, we're going to call a method here, show details, that if we go to its implementation, routes to a food details page where the route has a dynamic parameter name that's passed along. We can verify this in the browser where once the app loads up, we see all of our foods on our home page, and clicking on any individual one here takes us to that detail page, and you can see on this rendered page that there's a subtitle that contains the dynamic name matched on the route. In this case, that's banana. Other than that though, this page is obviously pretty bare since that name is all the detail we have about our food. If we go back to the editor though, and we look at our homepage component, down in its data section here, we can see that we have a property foods which represents the source data we're working with. For each individual food item, we actually have a property here, nutrition data, that contains much more information about a particular food item, and this is the kind of information we want to show on our details page. This is the kind of information we're going to set things up to pass along as a route parameter. For starters, let's go back to the top of this file to our template where we're rendering our food icon. As we just touched on, when it's clicked on, we're calling show details, passing in just a name, so let's go ahead and modify this a bit to also pass in the nutrition data for a particular food item. Once we do that, since this method is now accepting two arguments, we're going to have to go back to it and update its method definition to suit. We're going to give the second parameter a name of nutrition data, and in the method's body, in order to pass an object as a route parameter, we're still going to use our method here, this.router.push, but instead of providing the destination path as a string, as we're doing right now, we're instead going to pass in an object. Pasting it in, the object has a property name that needs to map to the name of a route defined in our app. So here we're saying food detail page because we do have a route with that name. Our object here also has another property we can define called params, which is then going to be an object that we can use to pass along more complex data. In our case here, we're adding two properties to params, the name again, and also our nutrition data. So that's step one, passing params via an object, but in order for this setup to work, there is one more thing we have to do when we configure our route. To do that, let's go to our routing file, router.index.js, and in here we can find our food details page route, so that's going to be starting on line 20, and we're just going to update it to have a new property, props, set to true. At this point now, the nutrition data property is available to us in the food details component, so let's go over to that component, which is stored in our file fooddetailpage.vue. And in here, what we want to do is set up a new computed property that we're going to call nutrition data that's going to be calculated by reaching into the route params object and accessing its nutrition data property. Getting a bit of space on line 22 and pasting this in, you'll note that it's basically the same flow as when we set up our food name computed property, where again, we're reaching into our route params object and accessing keys that we know are set on it. If I go ahead and save my food detail page, that's really all there is to it, where we've now successfully modified our food app to pass an entire object along as a route parameter. That said, here on our food detail page, we're not actually making use of all this new data. If we jump up to line 1 here, you can see we do have our template for the food detail page, but at the moment it just has a food app page wrapper that's wrapping nothing. To help us render out our nutrition data, we're going to quickly define a new component that's really just all about displaying nutritional information. We're going to define it as a single file component, so in my Explorer to the left here, I'm going to right click, say new file, and we're going to give this component a name of nutrition facts widget. Since the goal of this demo is not really to see how we can build up a new component, I'm quickly just going to paste in an implementation here. And without looking too much at its inner workings, I'll point out that it does accept an input property here that we're calling nutrition data, that it then displays in a nice visual format in its styled template. I'll also point out where our new component here is being exported as nutrition widget. With this widget in place, let's go back over to the food detail component, import our widget for use on line 9 here, and then register it locally on line 15. Once we have access to it, we're going to jump into our template here, and inside of our food app page wrapper, we're going to make use of a nutrition widget, making sure to bind its input property nutrition data to our local object of the same name, the one that we generated by reading our route parameters. So that's all the code we're going to write in this demo. Let's go ahead and save this and go over to the browser. And once our application reloads, now if we were to click on any of our individual food icons, it looks like something is broken. Let's quickly go back to the editor here, where I think the issue has to do with the name of our route. In our index.js file here, we've given the food detail route a name of food detail, and so in our home page component, when we set up our route object, we need to match exactly that name. Let's save this now, and then head back over to the browser, reload the application one more time, and hopefully now once we click on an individual food icon, you can see we're getting our details page and the nutrition facts are being broken down in our nicely formatted widget. We're set up here in a Vue app where we want to look at working with nested routes. We can use nested routes to help us structure our app URLs in such a way that it matches how our components are nested within each other to make up the app. The app we're working with is a food app where we've already defined one level of routing. If we look at our app's root component app.vue, we can see where we've placed our router view on its template in line 3. Further to that, in our app's routing file, router.index.js, we've gone on to define an initial set of routes that are being displayed by that router view. With this setup in place, let's now consider a scenario around our app's About page. If I open up About page.vue, existing as it is, its purpose is to give us some information about food in general, and then beyond that, we want to use it as a parent component where we can display more specific About page components for individual food groups depending on the app's overall URL. That might sound like a mouthful, but it's really not that complicated, and nested routes can help us achieve this. To get started, I'll point out that we've already defined a number of About components, one for each of the possible food groups. If we look in our Explorer to the left here, we have an About Dairy page, About Fruits page, About Grains page, About Meats page, and About Vegetables page, where in each of their respective files, they just render a simple template that lays out a paragraph with the specifics of that food group. Pushing on, now that we have these components, we want to be able to set up some straightforward and readable URLs for our app, things like about/dairy or about/fruits, that when we route to them, they render our generic About page component and then a more specific group component nested within that. The process starts by adding another route to view directive in our app, and this one is going to go into our About page component, since that's going to be the parent component, the parent that's going to nest the About group pages. So going back into About page.vue here, we're going to find some space in its template, perhaps on line 4, and I'm going to add in a new route to view. You'll note that even though we've added this route of view, we still have the ability to add anything else we need to this particular template, which is what we're doing in our paragraph on line 3 here, simulating some quote-unquote generic information about foods that's always going to show up. So now, with our nested route of view in place, we next need to think about configuring actual routes that can use it. Naturally, we're going to do this in our overall routing file, so going back to index.js here, the first thing we need to do is import About food group components. Scrolling to the top of my file, I'll get some space on line 9 and paste those imports in. Next, in order to set up some routes to use our nested route of view as opposed to our main route of view, we're going to have to create those routes as child routes associated to the parent component where we added that nested route of view. So in our case, we're talking about our About route here, since if you remember, that's where we put our nested route outlet. On this particular route, we can define child routes by adding a new property, children, defined as an array of routes. The actual routes we set up in this array are going to be set up with the same properties that we would expect, so things like name, component, and path. So let's paste in a number of routes here, one for each of our About group components. They're all set up in basically the same way, so let's just focus in on the first one here, the one for About Fruits page that we've given a name of About Fruits. Obviously, it's going to be able to render the About Fruits component, and it's going to be able to do so when the overall path of the app is at /about/fruits. If I save my updated router file now, at this point, if the user goes to our app and types in localhost or whatever their domain is, /about/fruits, we're going to see both the parent component, the About page component being rendered, and also that particular child component, About Fruits in this case, also being rendered within the parent thanks to nested routing. Now, before we go over to the browser and view this behavior, let's take one more step in our About page component and add some clickable router links to save our users from having to actually type in these long and nested URLs. Quickly jumping back into About page.vue here, we're going to set up some data with the variable routes, where routes is just an array of objects that we can use to help us generate our router links. With this routes variable in place, I'll just jump back into my template here and on line 4, paste in some code that's going to use route to link and v4 to dynamically generate a series of links that we can use for navigation. Saving everything now it's time to go over to the browser, refresh our application, and we start off at the home page as expected, but now let's go to our About page. Once it loads up, you'll note that the URL updates to reflect that we are in fact on the About page. And if we look in there, we see our one paragraph, our quote-unquote generic information, and also our navigation bar that should take us to each one of our food groups pages. If we click on any of these pages, you note here where our nested route now comes into play, rendering the specific child component inside of our parent About page component. Also, when we are viewing nested components like this, if you keep your eye on the browser bar, again you'll notice where it's going to be updated in a way that makes easy sense for our end users. Named views in Vue apps give us a way to display multiple routed views at once without any of them having to be nested inside the other. This is really useful in certain cases, like for example if we need to display and maintain a sidebar in our app alongside the app's main content. In this case, if we give our route to view outlets names when we add them to our component templates, then we can have multiple outlets exposed that we can target independently for routing. In our demo here, we're going to set up such a sidebar to give us a chance to dig into named views in Vue. To get started now, let's jump into our root app component, app.vue, which is opened on screen. At the moment, we just have one main route to view outlet set up on line 3 here, but what we're going to do is go ahead and set up another one. This one is going to be intended to handle our sidebar, so what I'll do is clear out our line 3 here and paste in a usage of 2 route to view outlets. Our original router view is now on line 4, and you can see here on line 7 we have a second router outlet here, this one with a name, right sidebar. You'll also notice that we've wrapped both of our router view outlets in their own divs, which gives us a chance to target those divs with class names, main, and sidebar so that we can style them down in our styles section. Continuing on now, if we look at our original router view, the one on line 4, you'll notice we've not added a name to it in the same way we added a name attribute to our secondary router view. If we choose to go this approach to not explicitly add a name, Vue is going to automatically assign a name as default, and it's going to use this outlet as the default outlet everywhere that we route in our app without explicitly selecting or naming an outlet. This is why when our app only ever needs one route to view, we're not required to add a name to it because it's just going to end up as default. So continuing on now, let's consider our sidebar component. We're creating and using it because its content is going to be somewhat unrelated to our app's main content. What you might display in a sidebar obviously depends on your specific business case, but common uses for sidebars are things like ads, or to display blog posts, or to even expose a search feature in your app. In our video, we're not going to get too deep into what our dynamic sidebar does, other than to say that it should serve a different purpose as the user navigates around to different parts of our app. What we're going to do now is quickly create a few page-level widget components that we can drop into our eventual sidebar. In my components folder, I'm going to create skeleton components here for an ad widget, a search widget, and also a blog view widget. In each of these single file components, we're just going to have a paragraph in its template to let us know its purpose. Once that's complete, now we have our named route to view and also some widgets to display in it, so we can now think about updating our routing file to route to multiple views. Opening up the routing file, which is in my router folder and named index.js, along the top where we're importing components for use, I'm now going to import my 3 brand new widget components. With these available to me, I can then drop into my routes array and update some of these routes to render those components. Now, in order to use named views, what we're going to do is map our existing path patterns to multiple views by modifying a particular route object. For example, looking just at our home route, we know that right now our path / is going to map to just one component, the home page component. As we well know, once the app loads up, the home page component is going to render in the default router view. The modification we're going to make here is instead of using the component property, we're going to get rid of this and set the components property, plural, as an object with key value pairs that are going to lay out how we can use multiple router views when this path is matched. Pasting in this component's key value pair, I'll point out here that our keys represent the name of route to view outlets, and the values represent components that should be rendered in those route outlets. That said, we've updated the home route, where the home page component is now going to render in the default sidebar, as it always has, but now when the path is /, our search widget is going to be rendered in the right sidebar. Again, right sidebar is the name that we gave our second router view outlet over in app.vue when we created it. So that's how named views work. Let's continue on now to update our food detail route here, where again, the default rendering stays the same, but when / food details is mapped, we're now going to show the add widget in our sidebar, and at the same time, we're going to update our about route here, where the right sidebar is going to show up our blog widget. Lastly, down at the bottom of our routing file here, where we have our favorites route, we're also going to update this so that when / favorites is the path, we're going to show in the main content area the favorites page, and the right sidebar is going to get the add widget once again. If we save everything now, go over to the browser and load up our application, when it does load up, we can see now already where the sidebar is visible displaying a search widget on the home route. Also, as expected, once I do start navigating around my different pages here, for instance, if I go to the favorites page, you can see where my sidebar is now using its own route outlet to show the add widget, so that's been updated as expected. And if I go to the about page, again, by taking advantage of named views, I can update my sidebar to now show a blog widget in a completely separate router outlet. We're set up here in a Vue app where we have some routing in place, as you can see on screen in our file index.js. In apps like these, it's often necessary to protect certain routes and not allow users to navigate to them for one reason or the other. Some examples might be like if the user is not authenticated, or perhaps they don't have a necessary permission or privilege to be able to see a certain route. Whatever the reason, Vue makes it easy to guard navigating to a route by using route guards. In our app here, let's pick a route that we already have set up. Our route with path food details dynamic name, for example, and let's just see how easy it is to restrict navigation at runtime to this route if we needed to. In this file, on the route that I want to guard, I can add a property before enter. Before enter is going to be set to a function that runs before Vue renders the associated route, and in this function, we can run our own custom logic to decide whether to continue routing to that route, whether to cancel navigation, or even if we need to redirect to elsewhere entirely. We've pasted in before enter on line 39, and you can see that when the function is called, it's going to receive 3 arguments. To, which is an object representing the route we can potentially navigate to. From, which is another object representing the route we are trying to navigate away from. And lastly, next, which is a callback we can use from within this function's body to indicate to the app how it should continue. Calling next and passing to it true allows the forward navigation to continue, whilst passing in false is going to cancel that navigation. If we call next and pass in a string path, it's going to effect a redirect in our app if the path is valid for the app. All that said, let's see something specific to this app so we can see how all of this route guarding works. Expanding out our before enter route guard here, the way our app, and specifically the food details component works, is that when it's created, it's actually going to expect to get some nutrition data being passed in as a route parameter. Knowing this, we're going to set things up so if there is no nutrition data, we're going to disallow routing to this component. Looking back at index.js, in our before enter, the first thing we're going to do is create a variable allow that's defaulting to false. We're then going to check the to route, the target route, its params object, looking for a nutrition data property. If that's set, we're going to set allow to true and call next with that value. But if there is not any nutrition data coming in as a route parameter, we're going to leave allow as false and call next, basically passing in that false. You'll also note here that for the purposes of our demo, we have a bit of console logging going on. So saving all of this now, before we see the application run, let's go over to our homepage component, since this is where our source food data is defined. If you look in this component's data, we set up an array here called foods, which is basically an array of food objects. Right now, there's just 3 foods being defined: apple, banana, and eggs, and you'll see where each of them actually has nutrition data set up. We're going to leave most of our nutrition data the same, but for our eggs here, since we want to see if our route guard works, we're going to comment out its nutrition data. Saving this now, let's go over to the browser, refresh our application, and once it loads up, we're going to start up on the home page. Now, if I were to click my apple here, we know that it has nutrition data set, so I'm able to go to food details for that. Looks good. Same thing for bananas here. But if our route guard works as expected, when I click on eggs, you can see no navigation is happening. And if I take a look at my console here, you can see I'm actually being told no nutrition data on that route, which is why we're using our route guard to block navigation. We're set up here in a Vue app where we have some routing in place, as you can see on screen in our routing file index.js. Oftentimes in apps like these, our users can be viewing a certain route, viewing a certain component, where for one reason or the other, it makes sense for us to know when they are trying to navigate away from that route, and for us to have a chance to intercept that navigation action. A good example is if a user is on a page with a form and then they make changes to that form and attempt to navigate away. In order to make sure that they don't mistakenly lose those changes, we can intercept when they try to navigate away and perhaps display a prompt to let them know that they are about to lose their changes, where their response to that prompt can either allow them to continue on and lose the changes or stay on the page and maintain those changes. We can implement these kinds of checks in Vue pretty easily by using route guards. To test one out in this video, let's go ahead and pick one of our page level components of our application. We're going to work with the About page here. And if I open it up, I'll point out on line 9 here that this About page component does have a nested router outlet, and also on lines 4 through 8, we're defining a navigation bar where each router link on this bar basically allows us to go to a different component page showing information about a specific food group. Now that we understand how this component works, we're going to set things up where when the user does visit the About page, we want to make sure that they then visit all of the nested food group pages before they can navigate away. If they have not yet visited all of the nested pages and they do attempt to navigate away, we're just going to prompt them to make sure that they do indeed want to leave. To help us out with this implementation, we've defined two methods here in our About page. So if I scroll down to my methods section, we're talking about our first method here, tag visit, which we can call passing in a string group name, where that string is going to be used to track that a particular nested page has been visited. In essence, it's going to take the group name and get that done by basically checking and updating the visited property for a particular route, where, as you can see on line 24, those routes are maintained as data in our routes array. Our second method, allGroupsViewed, simply returns a boolean that lets us know when the user has visited all of our nested views, and again it's going to calculate that based on the values of visited stored as data. So with our two methods in place, let's scroll to the top of our About page component here in our template, where I'll point out that for each of our router links, if the user does click the link, we're calling tag visit, passing in the group name of the link that was clicked. Calling this method is how we're getting our actual tracking done. So now, moving on, now that we have all of our wiring in place, in order to potentially restrict navigation away from this component, what we're going to do is add a property to this component called beforeRouteLeave. This is a top level property on my component configure object, so I'm going to get some space here on line 19 and paste it in, where the value for beforeRouteLeave is set to a function that tells the component how to respond if and when the user does attempt to navigate away. As you can see, the function when called is going to receive three arguments: to, which is an object representing the route we can potentially navigate to; from, another object that represents the route we're trying to navigate away from; and lastly, next, which is a callback that we can use from within this function body to indicate to the app how it should continue. Calling next and passing in true allows navigation away to continue, whilst calling false cancels navigation away. We can also call next and pass in a string path, and in that case, our route will be redirected to that path if it's a valid one for our application. Expanding out our beforeRouteLeave guard and considering what we're trying to accomplish, what we're going to do in here starting on line 26 is check to see if allGroupsViewed is false. If it is, this means the user has not yet visited all of our router links, so what we're going to do is show them a prompt and basically tell them that and ask them, are they sure they want to leave? When the user does respond to the prompt, it's going to come back to us as a boolean true or false, so we're just going to call next, passing in that boolean, and if allGroupsViewed was set to true, then basically mission accomplished, so we don't need to stop navigation away, so we call next, passing in true right away. What I want to do now is save my About page, so that we can then go over to the browser and see how it works. If we refresh the application, we're going to start off at the home page as expected, so now let's go over to the About page. And once it loads up, you can see our series of router links here that are going to load those nested components, the ones that give us information about specific food groups. If I go ahead and click on fruits, for instance, you can see the nested component loads up and I get a bit of information at the bottom of the page, as expected, but without clicking on any of those other router links, let's maybe attempt to go back to the home page. When we do that, you can see our beforeRouteLeave has kicked in. We have not yet viewed all of the pages, so this prompt is asking us, are we sure we want to navigate away? I'll go ahead and click OK, which allows navigation to continue, but let's go back again and maybe attempt to navigate out one more time, and if I were to click cancel instead when I get the prompt, you can see I stay at this page. If I quickly view all of my router links and then attempt to navigate away, if our app logic works as expected, the all groups viewed method should return true, and it should allow us to just navigate away. Now that you've had some time to become familiar with routing in Vue, it's time to test out some of what you've learned. In this exercise, you will create a Vue CLI app with a router view in its app.vue file and two single file components called master component and detail component. Next, you're going to create a route that maps / to the master component. And after that, you're going to create another route that maps / detail to the detail component. Once your two components are defined, in the master component, you're going to use a router link to navigate to the detail component. And then in the detail component, you're going to use programmatic routing to navigate back to the master component. Go ahead now and pause the video at this point, give the exercise a try on your own, and then continue this video to see what a potential solution might look like. We're starting off here in a Vue app where we have installed the Vue router via npm. We can confirm its presence by checking our package.json file, and on line 13 you can see our Vue router listed as a dependency. We've also created a few single file components in our apps components folder, and you can see them along the top of the interface as master component.vue and also detail component.vue. Over in our app's root component, app.vue, we're also adding a router outlet on line 3 so that this app can route. This app's routes are configured in our routing file, which is in the router folder named index.js. Opening it up, we've defined two routes on lines 11 and 12, one named master, which is going to map the path / to our master component, and the other named detail is going to map / detail to our detail component. With these two in place, we can now perform some routing. Firstly, to perform some routing using a router link in a component template, let's go into our master component. And if I expand out its template section, you can see on line 4 here where we've added a router link that has its target two attributes bound to a variable details path. Details path is being defined down in our components data, so if we expand that out, you can see it's simply going to point to the string / detail. Moving on now, if we want to see how we can do some programmatic routing in Vue, we can go over to our detail component. And in here, I'm going to expand out the methods object and show you the method we've defined called goToMaster. As you can see, it's going to route programmatically by using the router that's available to all components, saying here this.$router.push, and then I'm going to push on a string path, just a / in this case. In the template for this component, I've added a button on line 4 that when clicked is going to trigger our routing by calling goToMaster. To test all of this out, we can load up our app in the browser, and as expected, we start off being routed to our master component page, and if you click the Go to Detail button that we added to it, we end up at the detail page, and again clicking the master button is going to take us back, so we can now go back and forth using routing in Vue. Vuex is a state management pattern and library for Vue apps. It comes into play as our applications start to grow larger and start having to manage more and more state across its components. In situations like these, Vuex provides us a centralized data store that we can trust and refer to as a single source of truth, as opposed to having separate pieces of state being handled in multiple places in an app. We can install Vuex into a Vue app either at creation time, assuming the app was created with the Vue CLI, or anytime after creation manually by running the command npm install vuex. Once installed, in addition to being a centralized store for all of our app data, Vuex stores also only allow state modification through a defined, predictable, and understood process, saving us from any unexpected results. A Vuex store is created by using the Vuex store constructor exposed by the package. It takes a config object that determines how the store is going to be set up. Common properties in the config object are the state, which is where the actual data that we want to manage goes, mutations, which represent a set of functions that are the only way to mutate or alter the state data, getters, which are a set of functions that allow us to access derived or calculated state based on our business requirements, and lastly, actions, another set of functions that are for handling state mutation based on asynchronous operation. In conjunction, these are the major building blocks of a Vuex store, and they go a long way to providing us with a robust state management approach that we can add into our Vue apps with really no hassle at all. A Vuex store gives us a centralized way to maintain and manage state across our entire Vue app. Once we set up a store, then we can access its state from all of the different components that make up our app and treat that state as a single source of truth throughout the app. To create a Vuex store, the first thing we need to do is install the Vuex package, which we can do via npm by running the command npm install vuex --save from a terminal window open to our project folder. Since we use the save flag, we should be able to see our package listed as a dependency in our apps.package.json file when the process is complete, assuming all went well. So that looks good here, and once we have Vuex installed, next what we can do is define a place in our app to handle our store's configuration and logic. For us, let's create a new folder here called store in our source folder, and in that folder we're going to create a new file, index.js, which is going to be the root of our store. With our index.js all set up, in it, to set our app up to be able to work with a Vuex store, we first import both Vue and Vuex on lines 1 and 2. And next we're going to tell Vue to use the Vuex plugin on line 4 by saying vue.use Vuex. Lastly now, on line 6 what we're going to do is create and export a new store to round out our starter file. As you can see, to do that we're going to new up a new Vuex store by saying here new vuex.store, and to its constructor we're just going to pass in an empty configuration object for the time being. As you'll notice at the beginning of this line, we're going to make this here the default export for our index.js. This is all we're going to do in here, so let's save this file, and since we now have a store being created and exported, the next thing we need to do is go over to our file main.js here, which is where we're configuring our overall Vue instance, and in this file I'm going to get a bit of space here on line 5 and import our store, and then drop down into my Vue instances configuration and pass in my store just as we're passing in everything else. We're set up here in a Vue app where we installed Vuex to help us manage state. As part of the process, we created and exported a store in our file here index.js, and we've included that store as a part of the config options in our main app in our main.js file. In this video, we want to see how we can now start using our store by storing some state for us that the rest of the app can then use. To start off, we're going to go back to our store index.js file. The state that the Vuex store manages is going to be defined as the state property that we can set up as part of the store's options. In our app here, I'm going to jump into my store options, get a bit of space, and on line 7, I'm going to define the state property. You'll note here that the state property is set to an object that can then hold other properties. We're going to add a property foods into our state, and we're going to initially set that as an empty array. It's important to note that for everything that we want to store in our state object, we're going to have to provide a default value for it at this point, the point of defining it here. This is so that it gets tied into Vue's change detection properly, and Vue knows to watch it for changes that should then be propagated to other parts of the application. So now, after we've defined this foods array as part of our state, naturally, we then want to be able to add some food data to it at runtime. The only way state is changed is by using what's called a mutation function, so it's up to us to define these functions based on our app needs. Mutations go into the mutations property when we set up our Vuex store, which is another top-level property just as state is. In our app here, I'm going to get a bit of space on line 10, and I'm going to set up the mutations property. And again, as you can see, it's set up as an object, and this object is able to hold any number of mutation functions. Specific to our application here, we're going to define one mutation add food, which is going to allow us to add a single food object into our state. Pasting it in on line 11 here, we note that all mutation functions are going to get passed to them by default one parameter here, state, which is the state that it can then mutate. Any other parameters beyond this one are going to be optional, and really they're going to be dependent on your business requirements. They're going to be whatever you need to pass into this mutation to help you suitably mutate the state. In our case, we're going to pass in a food here, the one food object that we know we want to add to our foods array. Expanding out this mutation function now, we can see on line 12 in its body, we're just going to add this food to our foods array by saying here state.foods.push and passing that food to the function. That's really all there is to it for this mutation, and now that we have an initial state setup that's tracked and a mutation that we can use to add food data to that state, the next thing we would think about is to start refactoring this application to use this Vuex store, this state, as its main source of data. The way things are set up right now, at the moment, all of our app's food data is actually being defined over in our homepage component. So I'll open up homepage.vue, and you'll see here our foods array coming from this component's data property. Since we're migrating to using a Vuex store to handle our state, we're going to change this up a bit. For starters, we're going to set our state up in our root app component, which is located in our file app.vue. In here, we're going to jump into the component's config object, and we're going to hook into the created method of this root app component, essentially giving us a chance to modify our app state at startup. Expanding out what we just pasted into the created hook, you'll note on line 19, we're again going to define an array foods, and this is basically an identical array to the one we saw in the homepage component, but we're just setting it up here so we have access to it so that we can modify our state using it. If I contract this, I'll bring your attention to line 84, where we're basically going to set up a for each loop on our foods array, and on each iteration, we're going to take one of these foods items, treat it as a temporary variable f here, and we're going to add that item to our store's food state by using our mutation. We're doing this by accessing our store via this $store, and then we're able to access our mutations by calling the store's commit method. To that method, we're passing in the name of the mutation function we want to use. In our case, that's add food, and based on how we set up the function, we know that it then takes a food object, which is what we're passing in as f. I'm going to go ahead and save this now because that's all there is to it for this video. We've defined a mutation that we can use to add to that state, and then we're using this mutation elsewhere in our application, namely here in our app.vue component. At this point, the next thing to think about, now that our state has some data in it, is to refactor other parts of our application to actually use our state data and not data coming from anywhere else. We're set up here in our Vue app, looking at using Vuex stores to help us manage app state. To date, we've created a store with a state object that holds an array of food items in it. Beyond that, we've also added a mutation that we can use to add to that array one single food item at a time. Additionally, when our app loads up, our root app component app.vue has a created hook that uses some predefined food data along with our add food mutation to actually add some data into our state. In this video, what we now want to look at is actually retrieving this state data from and then using it in other parts of our application. We're going to get started in our app's homepage.vue, where we note that right now on line 26 here, we're defining an array foods that is really driving all of the app data. We're here in this video knowing that we now want to use our Vuex store instead of this hard-coded data, so what we're going to do is get rid of this foods array by simply commenting it out for the time being. That out of the way, obviously this component did have a dependency on a variable named foods, so we're going to replace it by creating an equivalently named computed property that then retrieves our state data. On line 103 here, I'm going to define a computed property, and in here I'm going to define a function foods. As we've learned about computed properties in the video titled Using Computed Properties, what we return from this function is then going to be available in this component as foods, so essentially it's going to replace the foods variable that we just commented out. Once what comes out of this property is an array of foods, then this should be the only change we need to make. On line 105 here, what we're going to return from this method is the result of a call to this $store.state, our overall state object, and then its foods property. As we've already seen, this is an array of food objects, so things should work pretty well here. Seeing is believing though, so let's go ahead and save our homepage component, go over to the browser and reload our application. And as you can see, when the application loads up, we're still seeing our 3 food icons, verifying that we're successfully reaching into our state and supplying our app with data using it instead of any other data. We're set up here in a Vue app that's using a Vuex store to help us manage state. In this video, we want to look at how we can use getters in our store to help us calculate derived state that other parts of the app can then easily use. Getters are similar to the computed properties that we would have in our components, but since they operate on our centralized state, it makes sense to define them alongside that state so that they can then be reused readily across the entire application. In our scenario in this application, we want to continue to refactor our food app to use Vuex store data across its many components. On screen, if we look at our homepage component, it used to define its own foods data in an array foods here, and then used that data to create its list of food icon components. We've already made an update though, so that all of our food data is coming from a computed property that reaches into the state to grab that data. That's one part of the equation out of the way, but if we stay in this component and in fact scroll to the top and look at its template, the way things are set up right now is that as we generate our list of food icon components, we're passing them a number of input properties about a particular food. Specifically, we're passing in input props for name, image, description, a food group, and whether or not this food is considered a favorite by the user or not. Since we now know that all of this data for an individual food item is actually stored in our state, we're going to see how we can refactor our food icon components to where we can just pass them an ID for a particular food item, and then the food icon component itself can reach into the state and grab that item and the rest of its associated details. As a start in this component, that means that we can just get rid of all of these input properties when we create our food icons and instead just pass in an ID. Saving that change we made on line 6, obviously, next we now need to go over to the food icon component itself and update it. That component's definition is in our Vue file foodicon.vue, so opening that up, we want to start off looking at this component's props object. Since we're no longer expecting things like name, image, is favorite, description, and group to be passed in, we're just going to delete here from lines 25 through 44. In place of those, we're nowhere passing in just the one input property ID, so let's get set up to receive that. So on line 25 here, we're just going to set up that one input property ID for which its type is numeric and we're saying it's required. We know this ID is associated with a food object in our store, so the next thing to do is to access that item. We can do this as a computed property that we're going to call food. So dropping into the set of already created computed properties for my component, I'm going to get a bit of space on the last one, and on line 57 here, paste in a new one that we're calling food. Expanding it out, you'll see on line 58 that in this properties definition, we want to reach into our Vuex store and retrieve the food with a particular ID. Although we have not yet set up this particular functionality, we are going to do so in a few minutes, and when we do, in our store, we're going to set up a getter called food that takes one parameter, a food ID. For now though, if we assume that this function is in place, we're able to use it as we're doing here on line 58 by saying this $store.getters, which returns to us an object with all of the store's getters, and then the getter we're talking about setting up is one called food and one that takes an ID. Like I said, we're going to be setting up that particular getter very soon, and when we use it, we're going to get back an object with some details that we can access here in this food icon component as food. Before we can move on though, in order to wrap things up in this component, we're going to need to update all of the places where we used our old input properties to instead use this food object and its details. Scrolling to the very top in the template section, initially where we set up our isFavorite value, we're instead going to use food.isFavorite. And on line 10, where we rendered out our food's name via the name input property, now we need to access food.name. Other than that, down in our computed properties section, we have some previously defined computed properties for tooltip, generated food icon style, and generated food icon classes that all need to be updated to use our new food object and its properties. Saving this file now, our food icon component is refactored. What we need to get into next now is our store config so that we can set up the getter function that we've already referenced. Opening up index.js. As we mentioned at the outset of the video, getters allow us to calculate and return derived state in a way that's reusable across the app. the getter that we're going to be setting up for returning a particular food item based on its ID is quite likely going to be a function that we use in many places in our application. To set it up, in our stores config here, the first thing we're going to add is a getters object, which is going to hold all of our getters. On line 15, I'm going to add that in, initially starting it off as an empty object. With that in place, on line 16 here, I'm going to paste in our specific getter function, the one we're calling food, and by default, a getter function is going to receive the current state as a parameter. In our particular getter here, we also need to pass in an ID so that it knows which food item it needs to search the state for, the food item it needs to return. When it is the case that we need to pass in more parameters to our getter, the way we do that is to have our getter function return a function that can be called that accepts whatever parameters we need to pass in. We're going to get all of this done in a one-liner on line 18, where, as you can see, we're going to return a function expression that takes in an ID that it then uses to search state.foods for an object with that particular ID. If it finds one, it's going to return that, but if not, then undefined is going to come out of this getter. So that's our food getter, but while we're here, let's go ahead and set up another getter for comparison's sake. We know that each food object has a parameter isFavorite that determines whether the food is a user favorite or not. If we wanted to set up a getter that could return all of the favorites from state, that would actually be a simpler getter since it doesn't require any extra parameters to do its job. To see what it looks like, I'm again going to get a bit of space on line 16 and paste in its implementation. So you can see we're calling this getter favorites. It takes the state just as our other one does, but the main difference here is instead of returning a function, it's just actually able to directly return the result of filtering our state.foods based on whether or not isFavorite is set to true. Like I said, we're not actually using this getter in this video, but it does allow us to compare getters that need parameters to those that don't. Jumping back into our food getter though, since we've completed this should actually end this bit of our app refactoring. All we need to do now is make sure everything is saved, go over to the browser and refresh our application, and as you can see, the homepage still loads normally, so it looks like we were able to successfully generate our food icon components by passing them just an ID and having them use that ID and our new getter to grab all of the data they need from state. As far as making calls to the network using HTTP, Vue by default does not come with an inbuilt library that handles this. On the one hand, this is good because it allows Vue to stay lean and avoid having extras in its bundle that our apps may or may not need. But on the other hand, this does mean that when we need to make HTTP calls, we have to find and install our own client, one that we trust. That said, one such client, the one we're going to be using in this video, and one that's quite popular for the cause is Axios. We're looking at its npm.js listing on screen right now, and it's a promise-based HTTP client for both Node and the browser that basically comes with much of the features that most apps need to be able to call out to the network and get things done. To get Axios installed in our app, we're going to go over to our app, and in a terminal folder open to our app's root folder, we're going to run the command npm install axios --save. The --save here should record Axios as a dependency in our package.json file, and so when the install is done, we're going to be able to verify that it was installed by checking for Axios in our package.json's dependencies section. We do see it here on line 11, and as you can see, at the time of recording this video, the latest available version was 0.19, but it's quite likely to have been updated from this version by the time you watch the video, so don't worry if your versions do not match exactly. The main thing is that once you have installed this package, you now have a solid library in place that can be used to make network calls in your Vue app. We're set up here in a Vue app, where we want to look at how we can use actions in our Vuex store. The main use case of actions is that they give us a way to work with our Vuex store asynchronously. In the video titled Mutating State, we saw how we can use mutations when we need to modify state. Mutations, however, are always synchronous, so when we do need to perform some asynchronous operation that should also have an effect on our state, then actions are the way to go. For instance, if we need to make a network call for some resource and then update our state based on the response, This is the kind of thing that's pretty common in web apps and also the kind of things that actions are perfectly suited for. In fact, that's the use case we're going to get into in this video, namely refactoring our food app to make a server call for its list of foods and then updating its own state based on the response. We've already installed Axios into this application to help us make our network calls, so the next step at this point is to jump into our Vuex store located in store index.js, where on line 3 here you'll see we've imported Axios for use. The next step now is to think about setting up an action. We define actions for our store in the actions property, so I'm going to get some space here on line 25 and set up the actions property, starting it off as an empty object. All of our actions are going to go into this object, and actions themselves are functions that receive a context object as an argument, where that context exposes to the method body a few properties related to state, some of which we're going to see leveraged very soon. Now, for the purposes of our demo and this application, what we want to do is create an action that can be used to get a list of foods from our server. On line 26, I'm going to paste in such an action, and you'll note we're going to call it getFoods, and as we just touched on, it's going to receive that context object. Expanding out getFoods now, in its implementation, we're going to be using Axios to perform a GET request by saying here axios.get, where the GET method takes as an argument the URL that we want to get from. In our case, we have a local server running on port 2222 that has an API we can call to get back an array of food items. Since Axios is promise-based, the result of this call is going to be a promise that we can then wait for with the then function. When our server does return, Axios is going to return to us a response object, and that response object is going to have a property data that contains the actual payload. As we mentioned a bit earlier, we do expect that this payload is going to be an array of food items, so we know we want to then take that array and add it to our app's state. The way to do that, to modify a state, is to use a mutation, and the way to call a mutation from an action is via the context object, which comes with a commit function we can use. All of this is what we're getting done on line 28, so when we say context.commit here, we're calling a mutation named addFoods, and we're passing to it our response payload. If for some reason our network request fails, on line 29 we're going to catch that, and we're just going to log out of the console, whatever the error was. Before we continue on now, let's take a quick round trip to Postman, where we can just make sure that our local server on port 2022 is indeed up and running. And if I make a call out to API v2 foods, I am going to get back an array of food items as expected. Okay, so that looks good. And now back in our store here, back in index.js, what we need to do now is actually define this mutation we're using here, the one called addFoods. The place to put that is in our mutations object, so getting a bit of space under our current mutation, I'm going to paste in a new mutation, and as you guessed it, the name of it is going to be addFoods. It's going to receive the state, and it's also going to receive foods, which we expect to be an array of food objects. In it, in order to modify the state, we have a simple one-liner here where we just say state.foods is equal to the foods that's passed into this method. That's pretty much all there is to it, so saving our store file index.js here, at this point we've created an action that allows us to make an asynchronous network call to get some food data from our server, and in that action, assuming our network call was successful, we're going to call the addFoods mutation, passing in the response payload, which then updates our app's entire foods array state. With all of this good stuff in place, all that's left to do naturally is to make use of this action. We're set up here in a Vue app where we've already created a Vuex action called getFoods that makes a call to our server to retrieve an array of food items that it then uses to update our foods state via the addFoods mutation. With this action all set up, naturally we want to be able to make use of it. To do that in our demo food app, we're going to jump into our file here app.vue, where at the moment in its created hook, what we're doing is actually hard coding an array of foods on line 19, and then using that array to set up our app's foods state by committing each of these food items individually. At this point in this video, we know we want to move away from this, so let's go ahead and comment out all of this, and instead get our list of foods from the server by using our new action. To make use of actions, what we need to do is dispatch them which is something we can do by accessing our store and then using its dispatch method. On line 86, we're going to do just that here by saying this.$store to access our store. Then we're going to call the dispatch method, and we're going to pass to that the name of the action we want to actually call, the action we want to dispatch, quote unquote. In our case, that action we know has the name of get foods. Based on this dispatch now, when the app view's created hook is executed at runtime, it's now going to trigger a network request, which then, as we've seen, is going to actually modify our app state to have some foods coming from the server side. Saving app.view, that's our action created and our action dispatched. However, before we run our refactored app in the browser to make sure it works, we're going to preemptively fix one problem that I know we'll have. If we go over to Postman and take a look at the response from the server when we use our Foods API, we can see that for each individual food object here, we're going to get back an image property, a path to an image for a particular food where that image is located in an images folder. Now, on the client side, if we attempt to load our image using just this path, it's going to fail because this partial location without the domain doesn't mean much to the client. That said, to get ahead of that, let's go back over to the editor and let's jump into our food icon component, which is where we're actually attempting to use our image. In this component's configuration object, what I'm going to do is create a new data property here. And the object we return from that data property is going to define a data variable image root that's going to be the domain we need to use to actually load our images from. With that domain in place, I'm then going to turn my attention to my generate food icon style computed property, which as you can see is going to return a CSS property for background image that's using a URL to load the food image that shows up on a particular icon. To make this work now, instead of just using the image that's passed in from our server, the one that we now know is going to be incomplete, I'll instead now generate this URL by basically combining our image root, the domain, and then the image property for a particular food item. Saving this update now, that's our refactor complete, and if everything works as expected, we should now have a full URL that requests an image from our food server. To test it all out, let's go over to the browser and reload our application, and if everything works as expected, as you'll see, we're still seeing our food icon components being generated, we're still seeing its background images being set properly, but behind the scenes, we know all of this is now coming because of the action we set up that's able to reach out to our server and get all of this information. In fact, if we look in our developer tools in the network tab, we can see where we're actually making the call out to our API, getting back our list of foods. And beyond that, you can see where we're actually making the calls to get back each of the images that's decorating our food icons. We're set up here in a Vue app where we want to look at using a Vuex action to help us post data to a server. In the video titled Using Actions to Save Data, we combined a Vuex action with the Axios get method to fetch data from our food server. In this video, we're going to follow a similar pattern, only this time we're going to use Axios to post instead of get. In our Vuex store file index.js that's open on screen right now, let's start things off by creating a new action. Jumping in here, I'm going to get some space on line 35 and paste that action in. And as you'll see, we give it a name here, post food, and it takes the Vuex context as its first argument, along with a food object, the one we want to post to the server, as its second argument. Inside of this method's body, as we just said, we're going to use the post method from Axios to perform the actual network request. When we call post, the first thing we're going to pass in is the URL we're posting to, and the second thing we pass in here is our payload. Now, Axios is promise-based, so what we get back when we use this method is a promise that we can chain on a call to then to in order to handle when it's resolved. On the back end, the way our server is set up is if a food is posted and saved successfully, what we're going to get back on the front end is a response containing that newly saved food along with a unique ID for it provided by the server. That said, back over here at the front end, once we do get back a successful response, it makes sense for us to update our local state with that new food, the food stored in response, so we're going to use our context object here, call its commit method, reference the add food mutation, and we're passing in response.data, which as I just said is going to be a food with an ID from the server. So this looks good, and now we have an action in place to help us create new foods both server-side and then locally assuming the server side was successful. To test this out, we need a way to actually define a new food that we can then pass along when we dispatch this action. We're going to keep things very simple in our demo app, so I'm going to save my index.js page here and go over to my homepage component. To save a bit of time here, I've already set up a few things to help us out when it's time to submit foods. In my template here on lines 8 through 9, you can see I've created a button that when clicked is going to call a method createNewFood, and if you scroll down into our components method section, you can see where that method is defined. createNewFood here on line 105. When it's executed, all it's going to do is reference our store, its dispatch method, and we're dispatching our new post food action, passing in a variable here, test food. This sample test food that we're using here is actually defined in our component's data up on line 90 here as a hard-coded object. A quick glance at its properties lets us know that the food we're creating here for the purposes of this demo is spinach. Naturally, in a real-world application, this food data to create new foods would likely be user-generated data, but for the moment, this hard-coded test food is going to get the job done. So at this point, we have an action that we can use to post. We have something to post, so if we make sure everything is saved and go over to the browser, once we reload, you can see we get our initial set of foods coming back from the server, and we also have our new Add Food button, which if we click it and everything works as expected, should dispatch our action, which should in turn submit our spinach food object to the server, and when that returns, we expect that our overall local state is then going to have a new food added to it, meaning we should end up with a new food icon, one representing spinach, on our home page. Vuex stores are used to store and centralize state data in an app in a way that makes that data a single source of truth that all other parts of the app can then make use of. At the moment in our app, our Vuex store state has just one property here, foods, that stores an array of food items. That said, if we continued on, as this app grows, we would naturally start adding more and more data into state. For example, we might add a blog post property to hold a number of blog posts that we can display in our app's sidebar, or we might add a search results property to hold cached keywords from user searches. If we added any of those new state items, then we would also have to add in any mutations, getters, and actions that we need for them to function. I'm sure you can already start to see how this one state file index.js can quickly start to grow into something less than easy to maintain in cases where we're adding in more and more functionality to support the different kinds of state that our app requires. In order to avoid this though, Vue allows us to break up our state representation into different modules where each module can take care of just a specific part of the state. For instance, let's continue on with our hypothetical scenario here and say that we now want to have our app support state for blog posts in addition to the already existing foods. To get that done, we're going to use modules, and to get started using modules, we're first going to set up a modules subfolder in our store folder. Inside of my modules folder, I'm going to define two separate files. The first one here I'm going to call foods.js, and obviously it's going to handle our food state related items. And the second file here I'm going to call blog.js, and it's going to deal with blog related state. Remaining in blog.js now, just so that we do have something to show here, starting on line 1, we'll just set up and export a store configuration object where that object has a state property with a key blog post, which is an array of objects that are supposed to represent our demo blog post. That's sufficient for this module, so next let's jump back to our original index.js file where we're defining our Vuex store and where basically all of the food related state is currently living. Since we're going with a modular approach here, we're going to be relocating all of this food state logic from index.js and instead into foods.js. Going into that file, the first thing I'm going to do is import Axios since we know we need it to make our server calls. And then just as we did in blog.js, we're going to export another configuration object here, where this one is going to handle everything to do with foods, everything that we just took out of our root file index.js. Saving foods.js now, we now have our two module files set up, so what we want to do is go back to our root store file index.js, and I can get rid of this import of Axios since we're not using it here anymore. And instead on line 4, I'm going to import food module and blog module from our two files. After that, the only property we need to add to our store object now is the modules property. Pasting it in on line 10 here, you can see we're going to set it to an object where we define two modules, food and blog, each of them set as an appropriate import. So that's really all there is to setting up modules in our state, but the only thing to consider now is that anywhere in our app where we accessed our food state the old way, we now need to modify that just a bit. Luckily for us, at the moment the only place we were directly accessing our store and its food state was the app's home page. So if I open that up, I can scroll down to line 115 here in our foods computer property, and where we were saying this.store.state.foods, we instead now need to say this.store.state.food.foods, where food is the name of the module we defined over in index.js. Once we access that module, we know it then has the state object that has the foods array that we're looking for. With everything complete now, we can now go over to the browser, reload our application, and if everything still loads up and functions as normal, we can be confident here that we've now updated our store to make it a bit more manageable via modules. In this video, we want to look at namespacing modules in our Vuex stores. To get right into it, let's consider our app on screen. Right now, its Vuex store is broken up into two modules, food and blog. Starting off in foods.js, let's define a new mutation just for the demo that we're going to call test mutation, and I'll set it up here on line 26 by pasting it in. When we actually do use this mutation, you'll note all it's really doing is logging a line to the console that says I'm mutating something from the foods module. Saving this, let's go over to our next module file, blog.js, and in here on line 12, let's define a mutations property, and in it, add one mutation with the same name, test mutation, where the only difference here is that it's logging a line that says that it's mutating something from the blog module. If we save blog.js now, we have two mutations in place, so the next thing I want to do is go over to my app.vue file, and in its created hook, here on line 88, attempt to commit a mutation with the name test mutation just by saying this.store.commit and passing in that string test mutation. So that looks good, and if we save everything, let's quickly go over to the browser, reload our application, and keep our eyes on our console. If we do that, we see that we're actually getting both lines of console output here, meaning that both mutations are being run. So behind the scenes, this is happening because when we tell Vuex to commit a mutation with the name test mutation in this case, it really has no idea which module that mutation is in, so it attempts to call a mutation with that name on each of its modules. If it does find such a mutation, it's going to execute it, and if it doesn't find one, then nothing is going to happen. In our case, we actually had a mutation named test mutation in both of our modules, so they both got executed, so we're seeing two lines of console output. This isn't a bug, this is expected behavior, but if you can imagine a situation where as our apps grow bigger, we might end up with mutations in different modules that share the same name that we don't necessarily want to run together all the time. For instance, different developers working on unrelated parts of code could easily create mutations with the same name without knowing it, opening up the potential for unanticipated behavior at runtime. Back over in our editor, if we don't want this kind of behavior, what we can do is namespace our modules. To see what that looks like, let's go back to each of our module files. We're going to start off here in foods.js, where on line 4, I'm going to add the namespaced property set to true. Once I save this, I'm going to go over to blog.js and do the same thing, namely adding a namespaced property set to true on line 2 here. And now, without changing anything else, let's go back to the browser and run our application one more time. Reloading and looking at the console again, now you can see we're actually getting some errors, the second of which is actually telling us about an unknown mutation type, test mutation. What's happening now is, because we've removed all of our modules from the global Vuex namespace, Vue is not going to call mutations on them anymore unless we're very specific about the module we're targeting. To do that, again, let's jump back to the editor, back into app.vue, and now when we attempt to call our mutation here on line 88, let's say that we want to call only the mutation in our foods namespace. Well, I can do that by updating my argument to commit here to say food/test mutation, where food now indicates a namespace module. If I save this and we go back and run the application one more time, there you can see we're mutating something in the foods module and we're not doing anything in the blogs module. Right above it though, we do still have this error about an unknown action type, and this is because dispatching actions works in a similar way if we're namespacing our modules. To see what I'm talking about, let's go back over to the editor and again back into app.vue, where on line 86 we're calling an action getFoods. Before our modules were namespaced, this worked without any issues, but now that the food module is namespaced, we actually have to update our dispatch call here again to indicate the namespace of interest. I'm going to go ahead and save this file, and while we're updating our dispatches, I know that I have some more in my homepage.vue file, so I'm going to open that up. Jump into my create new food method, and here where we were dispatching to post food, we know we need to now add the namespace food / ahead of that. Saving it all now, the next step is again to go back over to the browser and see how this works. Reloading the application, it seems like our errors about actions are gone, but now we're facing some errors about getters. There's a lot of wording here, but all this is highlighting for us is something that you've likely assumed by now, which is that we also need to update our calls to any Vuex getters to indicate a specific namespace. Back over to the editor another time here, what I'm going to do is search for all my usages of getters, and to do that I can search for this.store.getters, where it looks like I only have one here in my food icon component. So to access a namespace getter, the syntax is a bit different than what we saw for actions and mutations. On line 58 here, instead of saying this.store.getters.food, we have to actually index into the getters object and use a string that directs us to a namespace module. Pasting that in, we're saying now this.store.getters, and then in our square brackets, food /food, where the first food here actually indicates our namespace module, and the second food is the name of the getter we were looking for. Once we do get back our getter, we know that it does require an ID, so we're passing that in as well. Saving our updated food icon view now. If everything works as expected, we should be able to go back to the browser one more time, reload the application one more time. And if we look in the console here, we can see that all of the errors are gone. The app is working as expected, whilst behind the scenes, we're taking advantage of namespacing our modules. Now that you've had a chance to learn about managing state using Vuex, it's time to test out some of what you've learned. In this exercise, you will install Vuex for use in a Vue app, create a root store file index.js, initialize the store to hold an array of cars called cars, define a mutation that can be used to add one car to the store, define a getter that only returns red cars, and lastly, define an action that can be used to post a car to a server endpoint. Go ahead and pause the video now, give the exercise a try before continuing the video to see what one potential solution might look like. Manually installing Vuex into an app can be achieved via npm and the command npm install vuex with the save flag, since Vuex will likely be a central part of your app should you decide to use it. Once successful, you should then see Vuex listed as a dependency in your package.json file. Once installed, we can create a root store index file using Vue convention, which is to create a store folder in our app's source folder, and in there, a file we're going to call index.js. In our index.js file, we import Vuex and Vue for use, tell the Vue app to use Vuex, and then we can create and export our store using the Vuex store constructor. To have our store help us manage an array of cars called cars, we're going to add to the store's state object a property cars, making sure to initialize it to an empty array. To set up a mutation that can add a car to our state, we're going to add a function here into our mutations property that we're calling add car that's able to take a car that it then can push onto the cars array in state. Next, assuming each car object has a property color, we can add a getter to only return red cars by creating a method redCars in our getters property that filters our state.cars array, picking out and returning only those cars with color set to red. Lastly now, if we assume that we do have a server running that can accept post requests to create new cars, we can define an action here, post car, that accepts as a second argument the car that it should post, and then within this method's body, use Axios or your preferred HTTP client to make the post request passing along the car. When the result comes back, assuming it's successful, we're taking the additional step here of adding that car back into our local state. Forms are a big part of getting things done when our web apps need to collect user input. In Vue, the vModel directive can be used to help us set up two-way data binding between form inputs and our locally managed data, all in all making it very simple to collect and work with this user data. Whilst the vBind directive does already allow us to bind to component data and display it in our templates, this kind of binding is only one way, since that information isn't changed by the user directly once it's rendered. vModel, though, with its two-way data binding, means that when bound data is changed either programmatically or by the user, that those changes are going to propagate throughout the app. To see how this works, to start off, we've added a new single file component to our app in a file that we're calling foodadd.vue. We want to use this component as a way for our users to enter in their own data and create a new food item. Expanding out the component's script section on line 6 here, you'll note, as we mentioned, it does have a name of food add, and the only thing it's doing so far is wrapping its content in the food app page wrapper. To push forward now, let's define some data that should hold the food that the user is trying to create. Getting some space here on line 16, I'm going to paste in a data property, and in that function, return an object here that defines our data food. As you can see on lines 19 through 23, a food object can be expected to have its own properties for name, description, group, image, and also userFav, where they all have defaults set as empty strings, save for the name property, which we're going to default to this constant here, food name placeholder, and the user favorite, which is a boolean that defaults to false. This food object that we're creating here is going to be updated by our user as they enter data into our eventual form. To actually define this form now, let's head into our components template, get some space on line 3 here, and paste in our initial form. Now, as you might expect to see in a form, we're basically setting up labels and inputs here for each of the properties that we need to capture for a food. So that's going to be a text input for a food's name, a text area to give us a food's description, a select that's going to allow our user to select a food group, another text area to capture an image location, and finally, an input type checkbox where the user can define if this food is a favorite of theirs or not. Other than that, we have a submit button here, and outside of our form, we're just rendering out the component data property here, food, so that we can see it be modified on the fly when we're in the browser doing things. Saving this, as we said, right now this is just a regular form, so at the moment it isn't tied into or bound to our component data in any way, meaning that the next step for us to take to actually get our two-way data binding is to equip this form with a series of vModel directives, one for each input that's going to tie it to something in our component data. For example, if we look at our food name input on line 6 here, all we need to say is vModel is equal to food.name, and that's it. Quickly completing all the others, we're going to set up our text area here by saying vModel is equal to food.description, our food group selection by saying vModel is equal to food.group, our image input by saying vModel is equal to food.image, and lastly, we can perform two-way data binding on our input checkbox here for user favorite by saying vModel is equal to food.userfav. If we save everything now, this is a good first step. So let's go over to the browser, reload our application, and when it loads up, we're going to use our Add Food button here to take us to our Food Add component. On this component page, obviously we're going to see our form, and right away we can confirm at least one direction of data binding is working, that is from our component data up to the form, because we see this name input has already been set based on our placeholder text. That said, if I go ahead and start making any changes to my form here, we can see our food object being modified on the fly, confirming that the data binding is also happening in the other direction from our form's user input back down into the component data. We're set up here in a Vue app where we have set up a component containing a form that our app users can use to create new foods. In this video, we want to see how we can submit this form in Vue, assuming the user is done and presses the submit button. So the whole process starts with the user pressing the submit button, which we've defined in our template here down on line 31. When this happens, the native form submit event fires, and we should be able to then bind to that event on our form's opening tag, that tag being defined on line 3. Getting a bit of space here, I can perform the binding by saying @submit, and on the right side of the equal sign, we're going to specify a method to run when this event does fire. In our case, in our demo, we're going to say that method is onSubmit. At this point, naturally, the next thing for us to do is to define this method. Dropping into my components script section, I'm going to add a methods object here, and in there, define my onSubmit method. For the time being, all we're going to do in this method is log out to the console that the user submitted the food, and we're also going to log out what that food was. At this point, let's make sure everything is saved and go over to the browser and load our app up. Once it's ready, we can use the plus icon on the home page to take us to the food ad page. And then from there, I'll enter in just some random information about a food name, apple, and go ahead and just click the submit button. Before I do hit submit though, I'm going to pull up the console here. And now when I press submit, you can see down in the console, just for a second, we did get that line of output saying that the user submitted the food and what the food was. Right after that though, it disappeared because what happened is our page actually refreshed. The default behavior of form submissions is to refresh the page, which makes more sense when a form submission is tied to an action that posts your form data to an external API, the kind of form setup you're going to see in more traditional websites. That said though, our Vue app is a single page app and we want to initially handle our form submit client side, so we don't need that refresh behavior at all. To change that, we're going to go back over to the editor, back into our food add component, and up in its template, when we created our binding here, what I'm going to do is add a modifier to this to the end of my submit binding, which is going to prevent a refresh. That modifier is prevent, so I'm going to say @submit.prevent, and really that's all there is to it. Saving everything now, if we go back to the browser one more time, and I'm going to refresh our food ad page one more time, again enter in some food data, scroll to the bottom of my form, and submit one more time, you can see now I get my line of console output. We know that the user submitted a food. We can see what that food object is. And obviously here you can see we're staying on the page because we've used our Vue submit modifier to cancel that default refresh behavior. We're set up here in a Vue app where we're using a form and the v model directive to allow app users to define new foods. Eventually, when they do define a food and press the submit button, we want to send that food over to our server for saving. That said though, before we do go through the trouble of sending a request to the server, we should do some validation here on the client side to make sure that the food we're sending over makes sense. Our Vue app is HTML5 compliant, so we could go ahead and use native form validation abilities like the required field on an input, for instance. But in this video, we want to look at taking an approach of custom validation in our Vue app. To get started, in our food add component, what I want to do is scroll down to its data section and add a new data property here, errors, that we're initializing as an empty array, but that will eventually hold any errors should they arise. Next, let's define a new method that we can call on to help us validate this component's food object. Finding a bit of space in my methods object, here on line 65, I'm going to paste in such a method where you can see we're giving it a name here, validate food, and in its implementation, it basically checks to make sure that the food's name is not empty or the default placeholder text, and that the description, group, and image are all set to something other than an empty string. If any of those conditions fail, we're just going to push an appropriate error message onto the errors array, and at the end of everything here, we're going to return a boolean, true or false, determined by the length of the errors array. So this looks good. Now with our errors array in place and our validation method in place, it's time to go into our onSubmit method here, the method that fires when the user clicks the form's submit button, and modify it just a bit. Pasting in the update on line 64, now when this method fires, we're going to first use our validate food method to see if the food has any errors on it. If it does not, then we should be okay to submit to the server, which we can accomplish by using our VueX store's post food action. Now, if you need a refresher on posting to a server using Vuex, you can always check out the title, Using Actions to Post Data. What I will point out in this video though is that if we look at the post food action in our file foods.js, you can see we're using Axios to make that call, and Axios is a promise-based library, so we can actually return this promise when we do make the call. Saving this and jumping back into my food add component. Since we know that post food now returns a promise, we can actually chain on a call to then, allowing us to respond to a successful save by navigating back to the home page using our router. At the same time, we can also respond to a failed request, and here all we're doing is resetting our errors array and then pushing on a new string here saying that there was an error saving the food on the server. So this method looks good now, and the last thing we need to take care of with our food add component is actually rendering out these errors so the user knows that something has gone wrong. The easiest way to do that is to scroll up to our template section here, get a bit of space after our form, and here on line 34, I'm going to set up an unordered list where each list item is going to be generated using v4 on our errors array. Based on this setup, any errors in validation or server submission are always going to show up on the screen just below the form itself. So that's that. Let's save our food add component, pop over to the browser, refresh our application, and then navigate to the add food screen. Without doing anything else, let's go ahead and press the submit button. And there you can see at the bottom, we're getting a bunch of error messages as expected. If we go ahead and maybe fill in a bit of information for the food we're trying to set up here, a description, a food group, and an image, but intentionally we're going to leave name as the placeholder text and submit, you can see we now only have that one error message because the only thing we need to update now is the name. Let's go ahead and update that. And if we submit now, you can see that after the food passes custom validation, it then gets posted to the server, saved successfully, so we end up redirected to our home page where our latest food icon image is now showing up. Watches give us a way in our apps to observe and respond to when data changes on a Vue instance. Oftentimes, our business requirements make it such that we have some bits of data in our app that need to change based on some other data changing. Most of the time, computed properties are the way to go to get this kind of thing done, but Vue does provide a more generic mechanism to watch for changes, watches, that's a bit more flexible in terms of what we can do in response to changing data. For example, let's consider our app on screen. It's a food app that has a component food add, which is what we're looking at right now. This component allows the user to fill in a form and then submit this information to the server to create a new food. If we imagine we're looking down the road, we know that when this app goes live, lots of users are going to enter foods, and so there can be a fair amount of duplication coming into our servers for the same foods. That said, we want to save ourselves and our end users the trouble of entering data for a food we already have server-side. Here in this video, let's see how we can set that kind of functionality up using a watcher. Given our food form, what we want to watch is the name input, the input on line 6. We're watching this input because whatever name the user types in here is what we can use right away to perform a query on the server. Now, based on the results of the query, if the food exists already, we're going to disable the rest of the form, essentially letting our user know, don't bother. The name input, as you can see, is using vModel to basically two-way bind to a data property here, food.name. Actually setting up a watcher for this bit of component data is as simple as going over into our script section, where I'll get a bit of space on line 67, and start off by defining a watch property. Within my watch object, I'm going to add a key that represents the data that we want to watch. In our case, as we just touched on, that key is going to be food.name, so what we're saying here is our food data object and its name property, that's what we're going to be watching. Each time this data changes, we're going to be executing the function associated with our watcher. You'll note that the function that's called here is passed both the new and old values of the data that's changing, so that already gives us a fair amount of flexibility above and beyond what we can do in a computed property. In our particular demo here, we're not going to use any of these values, but it's good to know that they are available to us in a watcher. On line 70, in our watches implementation, you can see that each time food.name changes, what we're going to be doing is calling another method that we've defined here called searchFood. If I scroll down a bit now, we can jump into our methods section where we have defined searchFood. Glancing at what it's doing, In here, we're using Axios to kick off a request to our server, basically checking to see if a food with food.name already exists. If we do get one back, we're going to log out that, hey, this food already exists, and then we're going to set a data property here, food already exists, to true. At the same time, the way our server is set up, if the food does not exist, we're going to get back a 404, so we can catch that error, log out to the console that there was an error finding a food with that name, and instead set food already exists to false. With all of this in place now, let's go back up to the top of food add here into our template section and use our data variable food already exists to disable all of the form elements other than the name input, assuming a food does already exist. Quickly getting that done, you can see we're just binding to the disabled property of each of this form's inputs using the value of food already exists to control whether that input is disabled or not. Saving our app now, what we need to do is go over to the browser, reload everything, and once the app loads up, we're on our food add component. And if I click into my name input here and start typing a food name, apple for instance, you can already see in my console where I'm getting a lot of output where our watcher indeed kicks in actually on each character change, causing that query request to be sent off to the server. Going through a bit of our log here, you can see we perform a GET request with the search term A, and then another with AP, another with APP, and so on and so forth. So the watcher has worked as expected, which is a good thing, but unfortunately this is also a bit wasteful. At the moment, as you can clearly see, we're bombarding our server with search requests where most of them are going to fail. We don't need to perform a separate search for A, and then AP, and then APP, and so on, when instead all we really need to do is wait for the user to finish typing and then submit just the one search. Going back to the editor now, because we're using a watcher, we do have the flexibility we need to hold off on searching per character change and instead just wait a bit longer. Back in our food add component here, on line 52, I'll point out here that we've set up a created hook, and in there we're defining a property called debounce search. We're setting it by taking advantage of low-dash's debounce function to make sure that when it's used, the search food method is never called more quickly than once every 500 milliseconds. In effect, this means that if we used our debounce search in our watcher, then even though our watcher can and will pick up on changes as fast as the user types, this debouncer is going to throttle calls to the server by not calling the search method until there's a gap of at least 500 milliseconds between character changes. 500 milliseconds gives most typers enough time to finish typing a whole word. All that said, and knowing that we have this debounce search that we can use, let's go back into our watcher, comment out our direct use of this.searchFood, and instead use this.debounce search. Saving the app one more time, going back over to the browser one more time, and quickly refreshing. Now once the app loads up, I'm going to again search for apple. And if you kept your eye on the console, you already see much less console output, where in fact, based on our logs, the only time we ever queried the server for a food was when the whole food's name had been typed. Right below here, we can see the result here telling us that we did find the apple, and if we look at our form, that basically causes all of our other fields to be disabled. Clearly, this is a much more performant version of our application, and all of this we've been able to accomplish thanks to the utility of watchers in our Vue apps. Unit testing is a big part of creating apps that are maintainable in the long term. Vue supports unit testing out of the box using either Jest or Mocha and Chai. If your app is generated by the Vue CLI, then you actually have the option of getting testing set up in a functional way right from the very beginning. In this video, let's take a look at setting up a CLI app to have unit tests using the startup wizard and see what that gets us. Kicking off the wizard in the terminal at the bottom of the screen here, I'm going to say Vue create test app, where test app is the name of my app. If we want more granular control of the setup, which we do in this demo, we can choose the option to manually select features. As you can see in the next step, there's a lot of features we can tailor to our needs by adding them in at this point, but since we're just interested in testing for this demo, let's go ahead and leave Babel and Linter already selected and just go down to the unit testing section, press the spacebar to select it, and then enter to continue. In the next screen, I'm able to pick my linter, so I'm going to go with ESLint with Airbnb config, and follow that up saying that I want to lint on save. On the next screen is where we come to the unit testing section. As we touched on, we have two options out of the box, either using Mocha and Chai or Jest. Naturally, you're going to pick based on you and or your team's comfort level and familiarity with these options, and that said, I'm going to go ahead with Jest. To wrap up the wizard, I want my configurations to be in dedicated config files, so I'm going to select that option. And I don't want to save these settings as a preset, so I'm just going to use N here and press enter. Based on my settings, the wizard is going to go ahead and generate my project. Once the wizard is complete and our project is generated, we can go over to our package.json file and see in our dev dependencies section where we have a few test related packages ready to go. Namely, we have Babel Jest, Vue Test Utils, and the Vue CLI plugin unit Jest, where all of these three come together to give us a framework we can use to run tests immediately. In fact, if we look into the script section here, you can see we have a script we can run, test:unit, that's actually going to go through our project, search for all unit tests, and execute them for us. To try it out, I'm first going to change into my test app folder, and then I'm going to say npm run test:unit. As you mentioned, the script has run through our project, found that there were one test, executed that one test, and as you can see, that one test did pass. If you're wondering what and where these tests are, they're actually in our tests folder. So if I expand it out, you can see we have the one spec file, example spec.js, and there on lines 4 through 12 is the one test we saw, the one test that was passing. We're set up here in a Vue app where we've installed everything we need for unit testing with Jest. What we want to look at now is how we can set up and execute a unit test on a simple component. To get started, let's look at one of the simpler components of our app. It's in a file here, blog viewWidget.vue, and the component name itself is blogWidget. When it's created, you'll notice that its template just renders a div with a paragraph that says blogWidget. So there's nothing much to this component, but it is going to help us run through the basics of unit testing. To get that started, in my Explorer on the left of the screen, I'm going to go to my tests folder, into the unit subfolder, and then I'm going to create a new spec file here that I'm going to call blogwidgetspec.js. Once it's created, we're going to jump into it on line 1 here and set up a few imports. I'm importing Shallow Mount, which is a Vue provided test utility that we can use to mount components for testing, and also obviously we're importing blogWidget since it's going to be the component on the test. Creating my test now, I'll quickly paste it on a line 4, and so you'll see here we're starting off in a describe block named blogwidget.vue. Expanding it out, the one spec in here that we're calling renders with correct template is going to check to see that when the component is rendered, it's displaying the correct text, the text you might expect to see. Within my test here, on line 6, we're starting off by creating a constant wrapper that's set by using the shallow mount method and passing to it the component we're trying to mount, blogWidget in this case. The shallow mount method creates and mounts a component for us where, if that component has any child components, they are not rendered. In real-world applications, some of our components could easily have many children, and repeatedly rendering them all when we don't need to could just slow down our tests unnecessarily. If we did need those child components to be rendered for our test, we could just use the plain mount method also provided by VueUtils. In any event, shallow mount returns to us a wrapper around our mounted component where that wrapper has some extra convenience functions that make testing easier. One of them is the text function, which basically returns a string of what was rendered. Knowing that, we're setting up our assertion on line 8 here, where we expect that wrapper.text matches the regular expression blogWidget. Looking at our component, you'll remember in its template, blogWidget is some text that's being rendered out. So saving my spec file, I can then go down to the terminal and run all my tests here by saying npm run test:unit. And once we execute that, Vue should go through, find all of our tests, just the one in this case, run it, and hopefully it passes. We're set up here in a Vue app where we want to look at stubbing certain parts of Vue components when we set up unit tests for those components. The component under test in this demo is stored in the file pagewrapper.vue, and it's named Food App Page Wrapper. To get started testing this component, let's create a spec file over in my tests unit subfolder where I'm going to give that file a name of Food App Page Wrapper spec.js. At the top of the spec file starting on line 1, I'm going to import shallow mount, a Vue testing utility, and also the Food App Page Wrapper, the component that we want to test. On line 4, let's paste in our test here, but before we examine it though, let's take a look again at our PageWrapper.vue. If I look at this component's options, you can see it's actually expecting to receive two input props, title and subtitle, both strings, which are then rendered out in its template. Knowing this, we want to set up an initial test to verify that when we do pass in known inputs to this component, that what's rendered out contains the values of those inputs somewhere in there. Back over into our spec file now, our one test here is going to be named Food App Page Wrapper.vue renders correct title and subtitle. Expanding out the test, the first thing we're doing in here on lines 6 and 7 is defining two constants, two strings that we know about, title and subtitle. Next, on line 9, we're creating a component wrapper here using shallow mount, where the first thing we pass to shallow mount is the component we want to mount, the component we want to test, Food App Page Wrapper. The second thing we're passing to the shallow mount method here is an options object. We can use this object to pass in many types of things, one of which is prop data, so you see us here on line 10 passing in some sample prop data, basically our title and subtitle. With this mounted component in place, we can move on to lines 13 and 14 where we're setting up a few assertions. Essentially here, we're saying that when we pass in inputs title and subtitle, that we expect wrapper.text to contain both that title string and that subtitle string somewhere in its rendered text. So that's that. Saving our spec file now, we can go down to the terminal and run it here by saying npm run test unit. And once that's done, you can see our entire app had two tests, both of them passed, so we know that one of them was our Food App Page Wrapper test, but at the same time, if I scroll up a bit here, you can see I'm actually getting some warnings about my test. What we're being told here is that there's an unknown custom element route to link in our Food App Page Wrapper. Quickly jumping back over to the component itself, we can confirm that we actually do have 3 router links being used. Even though at runtime we know that Vue does know what a route to link is, here in our test environment, most things are not set up for us automatically because really we don't need most things in most tests. Case in point, in this spec, we're not really using the route to link, but at the same time, Vue is telling us that something may be going wrong. To get rid of these errors, one approach you can take is to simply provide a stub for route to link. Doing this is as simple as going back into our shallow mount options here and adding another one, key stubs, where its value is set to an array of things that we want to stub out. In this case, the one thing we do want to stub is route to link, so we add it in. Saving my spec file one more time, I'm going to go back to the terminal and run my tests again. And this time, again as expected, our 2 tests did pass, so our Food App Page Wrapper is included in that. And if I scroll up a bit here, you can see where we initiated our tests, and so basically we don't have any warnings coming up anymore. Mixins in Vue give us an approach to define and distribute reusable bits of logic amongst our app's components. We do that by defining said functionality in a mixin object and then mix that object into our components as we create them. To see an example, let's consider our app on screen. It's made up of a number of different components, but if I look into the food icon component, the one opened on screen right now, here on line 37, I'll bring your attention to a method here, logTelemetryEvent. Although its implementation is very much in a demo state, in a real-world application, each time this method is called, its job could be to log a telemetry event to a server based on the event's type and value. If we jump up to line 21, in this component's created hook, you can see we're actually using the method each time this component is created, logging a telemetry event where the type is component loaded, and the value is going to be the name of the particular component, food icon in this case. Now, with something like telemetry and logging when components are created at runtime, typically you're going to want to add this to each of your app's components so that you can have the most accurate data being logged. That said, To avoid having to define, maintain, and call this log telemetry event multiple times, once per component, let's see how we can set it up as a mixin. To start off, I'm going to create a new folder here, mixins, in my source folder. And in my mixins folder, I'm going to create a new file that I'm calling telemetry.js. Jumping into the file now, the first thing I'm going to do here on line 4 is create and export a constant telemetry mixin. Its value here is an object to which we can add any option that a component could normally have on it. Based on our discussion, if I expand this out, we know that we want our mixin to contain a created hook, so I'm going to provide that on line 5 here, and if I expand it out, you can see it's an exact duplication of what we were doing in food icon, calling the method logTelemetry event for an event type component loaded. Naturally, the method logTelemetry event also has to be provided, so we're providing that by adding a methods object to our mixin and expanding that out. Again, the method is exactly the same as we saw before. For the purposes of our demo, that's really all there is to defining this mixin. If I save it, what we'd like to do now is to go back into our food icon class and see how we can use it. First things first, we're not going to use this local version of logTelemetry event anymore, so I'm going to delete it from my created hook on line 22. And also delete the method itself from my methods object. After that, just so we can compare and contrast how mixins work, I'm going to go back into my created hook here and paste in a new line, a new console.log line, where we're just logging out a line so that we can appreciate that this created hook is still going to get called when we do use our mixin. So now, to use the actual mixin, I'm going to scroll up here, get a bit of space on line 16, and import it from my telemetry.js file. And then in my components objects, what I'm going to do is create a new property, mixins, on line 22, where its value is going to be set to an array that can contain any amount of mixins we want to mix into this component. In our case, we just have the one, so I'm going to just drop my telemetry mixin in there. So this looks good, and this is one place where we're making use of our mixin. But in order that we can see the actual benefit of mixins, we should use it elsewhere as well. Let's go into another component in our app, which is going to be our favorite widget. Opening that up, I again want to use my mixin, so on line 14 here, I'll import it for use, and then just as before, I'm going to jump into this component's objects, create a mixins property, and include my telemetry mixin in that array. If you make sure all of these files are saved now, we should be able to go over to our browser, make sure our app is reloaded, and then we're going to direct our attention to the console. If we look there, we can see that our mixin appears to be working, since now we are actually logging telemetry events for both our favorite widget and our food icon. We're seeing this multiple times because we have 3 separate food icons, and each one of those does have its own favorite widget. Beyond that, another thing I'll bring your attention to is the line after our food icon widget is loaded. You should recognize it as a string coming from the created hook in our food icon component, and we added it there to illustrate the point that when a mixin and an actual component have overlapping options, they end up being merged. In the case of a hook function, such as created, both versions of the hook are going to be called, with the mixins version always being called first, then followed up by the component version. In the case where the overlapping options are options that take data objects, then the data objects themselves are going to undergo a recursive merge, where any data in the actual component wins out over data in the mixin if there happen to be any conflicts. Global mixins are mixins that are registered globally and then applied to every component instance that's created in an app. They're very useful if we need to implement any kind of special logic for a component based on the custom option that component might have. For example, our app is made up of a number of components, as you can see in the file manager on the left of the screen. That said, only a few of them are page level components, and based on that, let's say we needed to run some custom logic on just those kinds of components. An approach to implementation using global mixins could first start with us defining a custom option on each page level component. To see how that works, let's start off here on our About page, where I'll jump into its options object, get some space on line 19, and paste in a custom property page level component set to true. Saving this, we're going to do the same thing for a few of our other page level components. So next, let's go to our favorites page and paste in our custom option on line 13. Then over to our food detail page and do the same thing, this time pasting in the custom option on line 14. And lastly, let's jump into our home page component here, get some space on line 20, and add in our custom option page level component to it as well. So now, with the custom option set up, let's define a global mixin. We're going to put it into our mixins folder, so I'm going to create a new file in there that I'm going to call pagelevel.js. And jumping into this file, on line 4, you're going to see us creating and exporting a constant global page level mixin. Expanding it out, we're setting up one hook here, the created hook. Now, since this mixin is going to be used globally on every single component in our app, it's important to keep in mind that whatever logic you add in here is going to be run each and every time a component is created, even third-party components that you may be leveraging. That said, the reason we added our custom option page level component to only the components we are interested in was to give us a way to filter those out from the larger batch of all components and to give us a way to apply our global logic to only those. In our created hook on line 6 here, we're checking for the presence of the page level component option by saying this.$option.pageLevelComponent. This is only going to return true for the components we modified, and so when we do get back true, we can then, inside of this if block, perform whatever custom logic it is we need to on just those components. In our case, all we're doing is logging out to the console that we found a page level component. We're going to go ahead and implement our custom logic for that component. Saving this now, the way to use a global mixin is to apply it to the Vue instance itself. In my main.js file, on line 4, I'm going to import my global page level mixin. And then on line 11, I'm going to register it for global use here by saying vue.mixin, where we pass in global page level mixin as the only argument. That's all there is to it. So now if we save our app, head over to the browser and reload everything. Once the app loads up, the only page to be created at this point is the home page, so you can see us capturing that in our log line here, implementing custom logic for the home page. And if I continue on to navigate to some of my other pages, favorites for instance, about for instance, you'll notice that even though all of these pages are made up of their own set of child components that are being created, the only place our global mixin with its created hook is firing are on the page level components. In addition to built-in directives like vif and vmodel, we can also define and use our own custom directives in our Vue apps. Custom directives typically come into play when we have some common functionality that we may need to apply to generic elements. They give us access to the element the directive is applied to, meaning that we can then modify the element in a low-level DOM way. As an example, let's create a directive in our app that can be used to hide any element it's applied to based on if a user has the correct permissions to view that element or not. To get started, let's create a folder, directives, in our source folder, and in there a JavaScript file, permissions.js, to hold our actual directive. Within this file, on line 3 here, we're going to stub out a simple method, checkUserPermissions, that we can call to query a user's permission level. Now, in a real-world application, your logic in here might depend on making a server call, or maybe a token or a cookie in browser storage, but for the demo, we're just going to return true or false to keep things moving along. Next, on line 8, to define my actual directive, I'm going to set up an object here as my default export. Directives have a number of hooks that we can bind to, where those hooks become associated with the element the directive is bound to. Based on those hooks, we can tap in and accomplish something with our directive. In this demo, the hook we're interested in here is the bind hook. It's called once when the directive is first bound to its parent, and that element is then available for modification. The function that we define when this hook fires is going to be passed a number of arguments, the first of which is the actual element. Here, we're going to receive that argument as element, and in our function body, what we want to do is check should the user be allowed to view this element based on their permissions. On line 10, we're doing that by using our checkUserPermissions property, and if that returns false, we're going to hide the element via CSS by setting its display property to none. To be very clear, we're not here implying that CSS is the way to enforce user permissions, obviously, but in order to keep our demo straightforward, this is the route we're going. So this is our directive created. Let's save it and next see how we can use it. Going over to my app's page wrapper component, we want to use our directive here to only show a link to favorites, our route to link on line 5, if the user has the permission to see it. To set that up, I'm going to get some space in my components script section on line 18 and import my directive for use. And then to register it locally, I'm going to go into my components options object here, get some space on line 21, and add a directives property where we're setting up a key value pair. The key is the name I want to use for the directive, and the value is going to be the imported directive object, the one we imported on line 18. Since we want both of them to be the same thing, permissions in this case, we get to use some shorthand syntax. Next, we can go up to this components template and use our directive by prepending it with v dash wherever we want to use it. As we touched on, we only want to display this favorites link if the user has permission to see it, so getting a bit of space on the opening tag here, I'm going to say v dash permissions. That's that, so making sure all my files are saved now, I'm going back over to permissions.js where we can ensure that all permissions are set to true. If we now go to the browser and load our application, we know that nothing has changed in our menu. Home, favorites, and about are all still visible, but if we go back over to the editor now and change our permission here to false, save and reload in the browser one more time, now when the app loads up, you'll notice there is no favorites link thanks to the work of our directive. So now, before we wrap everything up, at the moment in our app, this directive can only be used locally in the one page wrapper component it was registered in. If it so happens that the directive you need to create is one you expect to be able to use throughout the various components of your app, then you might want to register it globally instead of locally. To see how we can do that, let's first comment out our usage of our directive locally in page wrapper, and then head over to our app file here, main.js. In this file on line 5, let's again import our directive for use, calling it permissions, and to register it with the global app, here on line 13, we're going to say vue.directive, where the first argument is the name we want to use for our directive, and the second argument here is the directive that we imported. To make sure this works, we're going to save the app one last time, go back over to the browser, and reload the application again. And as you can see, the favorites link is still not visible, so the directive is still working, this time from a global context. When setting up custom directives for our Vue apps, we can end up needing to be able to pass params to those directives so that they can do their jobs. In this video, we're going to look at how we can pass params into our custom directives. To get started, our permissions directive, the one on screen, allows us to toggle whether or not a user can see certain elements in an app. At the moment, the way it's set up is that it uses a method internally, checkUserPermissions, that either returns a blanket true or false. If the method returns false, as in the user does not have the required permissions, then we use CSS to hide the element that the directive is bound to. Continuing on from this point, let's say now that we want to be able to extend this functionality so that we can check and grant permissions on a more granular level based on sections. To get that going, firstly, let's modify our checkUserPermissions function so that it takes in the parameter section. Here on line 3, I'm going to paste that in, and you can see where section is an optional parameter that we default to an empty string. Within our methods body, we're going to comment out everything we have right now, and just paste in a new implementation starting on line 7. In our new implementation, we're going to use the section property to basically index into a constant menu permissions that we have set up to return a Boolean true or false permission for a particular menu item. Right now, we support the menu items favorites, home, and about. Anything else, we're just returning a false. Saving this now, we now can go back to our binding for the directive here on line 20. Obviously in here, we now need to update where we use checkUserPermission to actually pass in a section. That said, looking at the way the binding is set up, right now we're not receiving any information we can actually use to pass in as section data to get a result. The way to change that is to accept a second parameter into our bind hook here. This one we're calling binding. So the binding object, the second param that's passed into the bind hook for a directive, has two properties that we can use to get info that's passed into the directive. Those properties are arg and modifier, both of which we'll see examples of passing in shortly. For now, on line 22 here, I'm just going to use ES6 syntax and destructure my binding, to create those two constants, arg and modifier. We're going to want to see what those look like at runtime in the browser, so I'm just going to log them out to the console for now as well. Saving permissions.js, we're going to leave it as it is for now, where we know that an arg and some modifiers can be passed into the directive. Let's shift our focus now to our single file component here, pageWrapper.vue, which is the only place in our app where we're currently actually using the permissions directive. You see it set up here on line 5 on our route to link for favorites, but at the moment we're also not passing in any data. To update this old usage and pass in some data, what we're going to say here is v-permissions favorites mod1 mod2. So now the first value after our colon becomes our arg, and then we can provide any number of modifiers by using the dot modifier as many times as needed. In our specific case here, our arg is favorites, and we're passing in two modifiers, mod1 and mod2. If we look at our entire usage here, you can already appreciate where it's easy to see that now we're checking permissions specifically for our favorites only when we use the directive here on line 5. Truthfully, we don't really need the extra modifiers mod1 and mod2 in this demo, but we do want to demonstrate that these can be passed into our custom directives if and when need be. Saving pageWrapper.vue, let's now jump back into permissions.js. To recap, we now know what to expect as an arg, one single value, and we also know our modifiers here is going to be an object that contains all of the modifiers that were provided when the directive was used. That said, to get the specific permission that the user is asking for when they use our directive, we can use this arg here since we know it's going to be the first parameter, and in the context of our demo, it's going to represent a section. Dropping down to line 28, we can then say check user permissions and just pass in arg. So that's our updated permissions.js file. Saving it now. To test things out, let's go back to our pageWrapper.vue where we have our menu defined. We're going to leave our setup the way it is on line 5, using it on the favorites link with a few modifiers, and we're also going to use our permissions on line 6 on our about menu item. To do that, I'm going to jump into the opening tag here where I can say vpermissions about. Saving this, we're almost ready to go over to the browser and check everything out here, but first let's make sure we know what to expect. Going back to permissions.js, right now favorites is set to true and about is set to false. So in the browser, if I reload my application and take a look at my menu bar, as expected, we can see favorites, but we don't see about. Let's quickly go back over to the editor, toggle these around just as a sanity check here. So we're going to change about to true and favorites to false. And once we save and reload the application one more time, now when we reload in the browser, we see the about link and our favorites link is gone based on our more granular permissions directive setup. Custom filters in Vue give us a way to apply common formatting to text and then return a resulting output. In this video, let's look at creating and using a custom filter. To set the stage, on screen here, we're looking at our food app and specifically its nutrition facts widget component. Let's say that our goal here is to create and use a filter that's able to take a string as input, insert a dash between each of its characters, and then return that new string as output. Getting started on that, we note that a filter is just a function that we define that takes in a string and outputs another string after processing the input in some way. Now, when creating a filter locally in our component, they go into the filters property of the component options. That said, I'm going to scroll down to my component options here and define a filters property on line 31. Inside of here on line 32, we're going to set up one filter that we're calling the delimit filter. The first argument into a filter function is always the input value to be processed. Here, we're receiving this argument as value, and without going into the line-by-line details of the filter's implementation, the long and short of it is that we're splitting the input string into an array, and then looping through the array using each character to generate a new string that includes our dash. At the end of it all, we're going to return our result. So that's our simple enough filter function, and with it in place, the next thing for us to do is obviously use it. One of the places filters can be used in our template is within our expressions. We're able to set them up by adding a pipe symbol after the expression and then the name of the filter. That said, let's try it out on line 4 of our template where we're setting up our header text. Firstly, I'm going to put my header text here into an expression, so into 2 curly brackets. And then I'm going to convert my string into a string literal here so that it's a valid template expression. And then I can follow that up with the pipe symbol and then the name of our filter, delimit filter. That's all there is to it, but while we're here, let's also use our filter somewhere else. Jumping into our H3 on line 8, let's apply our filter to a value coming directly from our template, that being the computed property serving size in grams. Applying the filter is the same formula, expression, pipe, filter name. Done. Saving everything now, let's pop over to the browser and reload our application. We start off at the home page, so let's then click into one of our food icons to navigate to the details page for it. And once we get there, you can see our header text, nutrition facts, and also our serving size here have both been affected by our filter, so we get those dashes between each of the characters. We're set up here in a Vue app, looking at how we can pass extra data into the custom filters that we create. Firstly, I'll point out that in the video titled Creating Custom Filters, we saw how simple it is to create and use a custom filter. In that video, the filter was registered locally to a specific component, but since then, we've registered it globally instead. To do that, we've moved the filter functions implementation into its own file, delimitfilter.js, and then in our app's main.js file, we've imported the filter for use, and then down on line 15, we've registered it globally by saying vue.filter, where the first argument is the string we want to use when we need to use the filter, and the second argument is the filter function that we imported. With that in place, let's now move on. Right now, our filter works, but it's not all that flexible in terms of the delimiter that it uses. Anywhere we make use of our filter, the output is going to be a string delimited with dashes. But what if we don't want dashes? Well, in Vue, it's easy enough to set up a filter to accept extra params since it's just a function. In our file here, delimitfilter.js, all we have to do is add any extra params we want to our function's signature. Getting some space on line 1, I'm going to set up another param here. Custom car, short for custom character, that we're initially defaulting to a dash. With that in place, in our function body, down on line 7, instead of hard coding in this dash when we create our delimited string, we're just going to get rid of that and instead use whatever our custom character is. Now, because custom character is optional, if it's not provided, we're just going to end up with the default dash being used all the same, meaning that these modifications we're making here are actually non-breaking, which is a good thing. Saving our delimit filter now, let's go over to our component nutrition facts widget, which is the one place we were actually using the filter in our app. Here on lines 4 and also lines 8, you can see our delimit filter being used. So in order to compare and contrast our filter's new functionality, we're going to leave line 4 untouched, but change line 8 to actually use a new delimiter. As we mentioned, this is really going to be as simple as passing in a parameter to a function. So here on line 8, I'm going to say delimiter, and then I'm going to pass in a new character, the asterisk in this case. The way this works now is at runtime when our filter function is called, the first argument to it is going to be the value of our expression, and the second argument is going to be our custom character here, the asterisk in this case. To confirm it all, let's save all of our files here. Go over to the browser, reload our application, and once it loads up, we're going to maybe jump into our banana food icon, where we can clearly see that our filter is working in both places. In our nutrition facts header, we still have our default dashes because we didn't make any changes there, but down in my serving size, now you can see where my string 118 is being delimited with those asterisk characters. Now that you've had a chance to work with forms and vModel in Vue, it's time to test out some of what you've learned. In this exercise, you will create a Vue component named class registration form. Next, you're going to add a form element to the component's template, and in that form element, you're going to add inputs to the form to collect the user's first name, last name, and age, where the age must be between 17 and 35 years old. After that, you're going to add a submit button to the form template that calls a method onSubmit, and lastly, display an alert in onSubmit that displays all of the user submitted form data. Go ahead now and pause the video, give the exercise a try before continuing the video to see what a potential solution might look like. Creating a new Vue single file component named class registration form starts with creating a file classRegistrationForm.vue. In that file, we're going to add the necessary components for a single file Vue component, so template, script, and style. To add a form element in our template, we use the HTML form opening and closing tags. And then inside of the form, we're going to use regular text inputs to collect the user's first name and last name, and the select here to collect the user's age. You'll note where each of these three inputs uses Vue's vModel directive to perform two-way binding to the component data properties first name, last name, and age respectively. You'll also note on line 14 where we use the v_for directive along with the valid ages array that I'll show exists in my script's data property to generate the age options for our end user to select from. When it comes to form submission, we're defining an input of type submit in our form on line 18, and then in our form's opening tag, we're going to bind to the submit event by calling a method onSubmit. If we look at this method's implementation down in our component's methods property, you can see that onSubmit, when called, is basically going to create and display an alert that outputs our user's full name and age. Making sure everything is saved, we can easily go to the browser, load up the application, and then test it out here by entering a first name, a last name, and then an age. If I press submit now, as expected, we have our alert with all of our user captured information.